Hey guys, how are you doing?
Good. How are you guys?
Good. What I might do is just change the settings a little bit. I think I can do it in the participants view. Yeah. Um, I've just changed it so we can turn on the waiting room. So people start turning up. So the other workshop I was in, some people started turning up half an hour or 1 hour early.
Yeah, I see.
So if we turn this now, we can make sure it's just us that's in the session. I want to share with you the welcome slides I made, and then to see what you guys think, and then we can talk a little bit about the schedule, and hopefully Barrett will join us shortly because he's been putting together some material for the breakouts. So we just see if I can get open my PowerPoint, and we have our keynote. One of them, Kay Stanley, she's been having problems getting onto the platform, but I told her once I started once the link was started, then she should be able to connect. So we'll see if she comes in as well. Anyway, let me share my screen, and oh, there's Kay right there. That's great. Hey Kay, can you hear us?
Hi.
Hey, well done, you made it.
Yeah.
Okay.
Hey.
I'm not sure if you've met Tobias and Arash before. Tobias is from University of South Australia, and Arash is from Meta. So,
Nice to virtually meet you.
Yeah,
you
nice
want
to meet you.
to maybe try sharing your slides just to make sure. I'll just make you co-host because I've been in a couple of I wonder why I can't make you co-host. Oh, it's because I'm not the host. Oh no, I should be able to. Huh. That's really strange. Yeah, can you do it, Tobias? Because you're a host as well. Can you make Kay a co-host?
Make co-host.
Yeah.
Yeah.
Okay. Yeah, please do that because for some reason it wasn't showing.
I think you should be a co-host now. Okay.
Oh, she is. Perfect. That's great. Great. So do you want to try and share your slides? And I guess we should check if you have any audio in the slides. We should check to make sure they're right.
I don't have it. Only me.
That's great. Perfect. No, that's good.
So this is just this.
Oh, perfect. Very smooth.
All right. Should I take that down now?
Do you want to go full screen just to make sure it will work? We're seeing the presenter view now, I guess, or the. Yeah, perfect. That's great. Very good. Okay, excellent. So I'm going to share my screen now. So I'll grab that from you, and just to talk with everybody about the welcome. So this is what I put together. Okay, so we have everybody. I hope those pictures are okay for you all. I just grabbed them from the internet. So I thought at the very beginning, not all of us will be here. Saranga, I think, is on holiday right now, so I don't think he's going to join us. But those who are, we could give a brief intro to each other. And then I have a little bit of one slide kind of provides some context and talking about how important health and safety is for AR and VR. And then a little bit about the workshop goals for presenting topics, identifying key areas of research, and hoping to grow the community of researchers. And then say, it's a very important area for research. So here's some potential topics for research, although we're not going to be touching on all of those. Then here's our schedule. So Kay will have her keynote starting in actually probably earlier than 10 after 11, but we'll see how it goes. And then we have 1 hour paper presentations. Each person is supposed to speak for 15 minutes, and then one should have 15 minutes at the end, which will actually run straight into Richard's keynote. So we may want to take a short bathroom break, depending on how it goes, before his keynote. And then there's Richard's keynote, and then we have our brainstorming activity, and then the workshop closes around 2 o'clock. The brainstorming activity, we can shorten the time if we need to, because we're probably running over time. So Kay, for you, I guess we had allocated 30 minutes in total, so hopefully around 20 minutes or 25 minutes for a presentation, then 5 minutes or so for questions.
Okay.
How it goes. Oh, and
Mark, can I ask you, in terms of like the Sherry Leung, or like the presentations from Hong Kong, I think the first author was someone else. Have you sort of checked with them who's
yes, I got an
presenting?
email from him. He can't make it, so
Okay.
he asked Cheryl to present instead of him.
Okay,
So
thank you.
it's actually great. We're going to have 4 or 3 women presenters for the papers and 1 woman keynote. So it's really good to kind of reverse the diversity
Fantastic.
problem we have in this, which is great. And then here's a slide for UK. I'll just briefly introduce you, and hopefully that material is all okay. And then I put together, this is the 3 paper presentations, and here's the presentation for Richard. Actually, Richard probably might want to send me a different picture, so I emailed him for bio information but didn't get any feedback, so I'm not sure, Arash, if you can ping him or something. And there may be some other details he wants added to his slide, but we won't show that until after the papers, so we've got like an hour to update that as well.
So if you can share this slide with me as well, then I can check, because Richard is not research program manager.
Okay, sure. I will email you the slide, and then you can make some changes. But yeah, I went to his LinkedIn page and pulled some stuff from that. But I asked him yesterday or day before yesterday to send me a bio, but he didn't. He probably has a different picture as well. That picture is kind of like a mugshot, so he probably wants something different.
This is what I have from him as well. So
yeah, okay. Well, that's from LinkedIn too. And then that's it basically. So does that look okay in terms of the slides for the intro and welcome?
Good to me.
Great, yeah. Thanks, Kay. And then that'll lead us to if I go back to here, so we had the schedule. So just in terms of what people are doing, so I was going to run the introduction and then the welcome, and then let me just look at my email. I sent an email out yesterday, didn't I, with everybody's other activities. Not that one. This one here. And I believe that Mingxi was going to introduce Richard, and Tobias was going to run the paper session, and then Arash and Barrett were going to do the breakouts for the brainstorming. And we may need a third breakout session depending how it goes. So either Aaron Dum or Mingxi could do that potentially. Does that sound okay? Barrett, did you want to talk a little about the breakout sessions, because you've made a Miro board?
Yeah. So do you want to recap how you want this to go? I think so. We're going to have 2 or 3 groups.
Yeah, it depends how many people we have. So I just came from another workshop, the one on XR and health, and they had 50 people on their workshop, which was huge. When the workshop I taught yesterday on empathic computing, we started off with 40, but then by the time we got down to the breakouts, it dwindled down to 10. So it seems like people stay around for the presentations, and then when we talk about breakouts and having to do something, they all leave and go have lunch or something. So we'll have to see how much we have. So I would think we want to have probably no more than 10 people in each breakout room.
Mhm.
So yesterday,
like-
as I said, because we dwindled down to 10, we just had one breakout session. If we
Mhm.
have more than that, and so by the time we get to Richard's keynote or the end of Richard's keynote, we should know how many. We could then break into multiple Zoom rooms with hopefully 10 people in each one. So I'm thinking probably 2, maybe 3 if we need to.
Yeah.
And then,
Okay.
as I said on the email, we could basically, and we may need to shorten the time a little bit, because I suspect by then, if we want to put a bathroom break in, for example, after the paper presentations, then we may actually be starting Richard's keynote speech more like 10 to 1 rather than 20 to 1, which means the brainstorming might start at 1:20 rather than 1:10, but we'll see how it goes. So we may have half an hour or 45 minutes, depending on that. And the idea is that was basically to get each group to quickly, with the first 3 to 4 or 5 minutes, to make a bunch of post-it notes individually about what they think the important research topics are in health and safety. And then for the next, after they've got that, then you'll probably do maybe 5 minutes or 10 minutes of clustering. So with 10 people, you might get 20 or 30 topics, and then you say, okay, let's see if we can cluster them together, and everybody should basically see if they can find related topics and cluster them, and then which into themes. So then you probably have 6 or 8 themes, depending how it goes. And then in the remaining time, it will be good to talk amongst the people to figure out which of those themes they think are most important. So you could do that by giving everybody some votes and say, okay, well, you've each got 3 votes now, and so now you can each put 1 vote beside the top 3 themes that you think. And then at the end of that time, when we come back together at 1:55, we can then give time to each of the breakouts for them to talk about or present what they think are the 3 most important themes and why. Does that kind of make sense?
Yeah, that makes sense. I think so. So each of the groups is kind of doing this in parallel. They're not starting with any specific topics or themes or anything like that.
That's right. Yeah. So they should come up with the themes themselves.
Yeah.
And
Okay.
of course, we'll hopefully capture all of this anyway. So even if people, so through that we might get 15 or 20 research topics or research themes that people have done.
I think it's a good idea.
Yeah.
And then you see what different topics the different groups come up with when they report at the end.
Yeah, exactly. So it'll be good potentially to have somebody who's not one of the workshop organizers to be the reporting person, and hopefully have done enough discussion inside the breakout that they'll be able to say why they thought these 3 were important.
Yeah.
They might say, oh, we think distraction and AR is really important, and that's because AR is really an attention dividing technology, and if you're doing outdoor gaming or whatever, then being distracted from the real world could actually be detrimental to your health. So that's one of our important topics.
Yeah, I think this is a good idea. I think because it's a short time, we could try and combine like the first 2 parts, like the idea generation and the clustering, and try and do those.
Well, I think you might want to have the idea generation. Well, you could try it. You want to make sure people are not starting into the evaluation phase yet. So so if you want to combine that, it's great. But just make sure people are encouraged to generate a lot of individual ideas as well. Generate as many ideas as possible. So that would be great. But yeah, you could do that. It's up to you guys as the chairs. So Arash and you, Barrett, as the 2 breakout brainstorming chairs in terms of how you want to do that. But essentially, you want to run through at least 2 or 3 phases. So first phase is generating ideas, then clustering into themes, and they could be combined, like you said, and then basic evaluation and deciding have some discussion about which you think is the most important.
Yeah, it'd be good if there's time to talk about those topics a little bit as well. So try and flesh out what.
So that would be the idea in the second part. If you can do the generation fast, maybe in 3 minutes or so, and then the clustering could happen in 5 or 10 minutes, and then hopefully you'll have 20 to 35 minutes left for the discussion. And of course, during the discussion phase, you may decide that you want to change some of the clusters. You might think, oh well, actually, this topic we put in this theme actually could also be in multiple themes, so it could be another theme as well.
Yeah.
And maybe these 2 themes could be combined together into a more general topic or something like that.
Okay.
Does that sound okay?
That sounds good. Yeah.
Quick question. So sorry, are we going to have Yeah, are we going to have two Miro like links? Because we only
Yes,
have
so
one.
Barrett should have created a couple of those actually, Barrett. I don't know if you can copy the
I will,
Yeah.
yeah. I'll probably tweak the board a little bit here. I'll just share.
yeah, so you've
what
got some
looks
time
like
to work
the-
on it. We're not doing that for another
Yeah.
hour and a half, but yeah, if you could create potentially 3 boards, and then we'll do a breakout room, and then we'll paste the link to the Miro board into the breakout room, and then you can start doing that. And then when it comes to reporting back, you could share the screen when they do the reporting and say, this is our board. Here's the top 3 that we made, kind of thing.
Yeah.
So you want to make one board and have each person working on each group
Well,
working on
I
the area?
thought we could have done this before, but I think if they're, because then if they're doing this in parallel, then they'll end up copying each other. So I'll make them
Yeah.
separate boards.
Yeah, I think that's a better idea.
Working
Yeah.
independently. But what I'll do is I'll make a workflow. So I'll make a starting area on the left, and then
Oh, perfect. Okay,
another
that'll be
second clustering area, and then a third area for
a presentation or something.
yeah. And then I'll copy that, and I'll make a board just in case.
That sounds perfect. That'll be super great.
Also, is there any mechanism here to vote, or like we can kind of like come up with other ideas? Because for another one, I know that you can vote, but here I think we can have like a shape or things like that. I'm not sure.
I don't think you can, but you can do stuff. I mean, if it's only a group of 10 people, you can do like a show of hands, or just through discussion, or you
Well,
can
what you could do is say each person could put a dot beside the one they
Yeah.
like. So you can have basically say people take 3 circles, and just drop 3 circles beside the ones, 1 circle each one's.
yeah, or just draw a mark using the pen. Like that, by the ones that you like, or something like that. There's lots of ways to do it.
Yeah. Okay, let me just I'll just email. I actually just got to get a new picture for Mingji. I used the wrong picture. Sorry about that.
Yeah, no worries.
Probably
Just a question
somebody-
about the mirror. So if we are in a breakout room and someone joins in late, are they still able to join in one of the breakout rooms?
Well, I could stay separate from the breakouts, and I could watch for people joining. So I could stay on the main Zoom link if you like. Actually, I'm not super proficient with using breakouts, but I presume it's pretty easy. Or Barrett, do you know how to use breakout rooms easily?
I do, but you can. I think only the host usually can do it.
Okay. Well, we can make you a host, but then can you join? Well, I guess you can join your own room, and then
Yeah.
I can stay on the main Zoom link.
Oh wait, I do have breakout room access. Yeah, I can do it.
Yeah. Okay.
You can also let participants choose, but maybe we don't want to do that. I think you could still see the waiting room from when you're in breakout rooms, as far as I know.
I don't know, well, but I'm certainly happy to stay out of the breakouts and then jump in, and when somebody comes in, I could push them into a breakout room. And yeah, it doesn't really matter which room they go into, but I guess it's as long as we try and keep the numbers equal.
Yeah, sure.
So we could just go down the participants, go 1, 2, 1, 2, 1, 2, and just push them into the rooms alternatively.
Yeah, it's quite easy. Let me know when because you'll be busy with other things anyway. So just I can create the rooms when you're ready. Just let me know.
Oh, that'll be great. Yeah, sure. I'm just going to change the picture for Mingji because much better one.
I
Yeah.
also do have a question regarding the Q&As. So do I understand it correctly? So the questions are asked over Discord, over the Discord channel?
They can be over Discord or over chat. So I think what we need to do is make sure. If you're running the Q&A from the paper session, Tobias, well, like I said, all of the Q&A will happen at the end. So we do the 3 papers and we do them all at the end. And then if you like, if you want to monitor both, or I can monitor the Discord and I can send you a message on Zoom chat, a private message saying, here's a question on this one.
Okay.
Yeah.
So the chat function is on for like the participants. They can ask through.
Yes, they should be able
Okay.
to as well.
So I just tell them they should preferably ask the questions through Zoom, the chat function.
Well, actually, the Discord is better because the questions stay there. So
Okay.
the people who may want who have some questions after the workshop is over, they can still keep on using them because they'll have the recording as well of the workshop. So I think Discord is probably the preferred way.
Okay.
The one other thing I didn't talk about is that we haven't made the papers available, but and actually Yunhee doesn't have a paper, I don't think, because she's an invited talk. So we really only got 2 papers from Anchoret and from the University of Hong Kong. But if it's okay with them, we could put those into the Discord as well, the link to their submissions, and which some other workshops have done. So I guess I can check with them to make sure that's okay. And then some other people have also put them onto the website. So if it's okay with them, we could add that too. And we could add the recording as well. I think we've got, Kay, is it going to be okay to record your keynote? Is that okay? Okay, that's great. And Arash, I think we've got permission from Facebook or from Meta to do recording for that as well. So we can do that. So I'll just send you an email now, Arash, with the slides. So if you can fix the Meta one. And then I guess we're about 5 minutes away from getting started, so we can probably start letting people in. Does anybody have any other questions, or is that pretty good?
I mean, with the Q&A, if I miss something, yeah, if someone just steps in and I'll point into the question.
Yeah, we can just message you. If you just keep your Zoom message channel open, then we can use it as a side communication.
Awesome.
And I guess, Mingji, you're going to introduce Richard, but you don't really know much about him. So Arash is going to give a update the slides that I put together. And there's also a LinkedIn page that I can send you if that's helpful.
Yeah, I know his LinkedIn page. So all I know about him is from his LinkedIn page.
Okay. Well, that's he was supposed to send a bio, but he didn't. But maybe he'll get back to us quickly. Maybe Arash, if you send him a message on Meta's
I did. He didn't get back to me, unfortunately, yet. So if I have, I will.
Well, I'm sure, and it'll be good actually if he tried to. Some of the other keynotes from other workshops have had some trouble getting onto the Zoom platform. So hopefully, sometime in the next hour or two, he'll be able to try and make sure he can join as well, because for some reason, some people had a hard time. Okay, I think we're all good. Does anybody have any other questions or concerns or anything?
Just one request. Can you add me also as the co-host for the breakout? Maybe I need to kind of like.
Yeah. Well, I was having some trouble with that.
Yeah,
I
can make you a co-host. Yeah.
Yeah, please do. Yeah. So for some reason I was maybe because I didn't join first or something. I think Tobias is already there. But yeah, it'll be great. Yeah, you should make sure Tobias, everybody's a co-host, like Barrett.
It should be a co-host now.
Yeah, everybody's co-host right now. Great.
Aaron Dunn is in the waiting room. Should we let
I should admit Aaron Dunn, yeah, for sure. Hey, Aaron Dunn, can you hear us?
Hi, Mark. Yes,
hey.
I can hear you.
Can you make him a co-host as well, Tobias?
Yeah.
So I'm sorry. I hope you weren't waiting for long. We just went through the welcome slides. And it seemed to be okay.
Oh, okay, and, no, that's great. No, it's not long.
There's actually not much for you to do, but we just discussed that if we have a lot of people going into the breakout at the end of brainstorming, then we might get you to run one of the brainstorming sessions if that's okay. So
sure.
Currently, Arash and Barrett are doing 2 sessions. But if we have the need for 3, and it'll be kind of like what happened yesterday. And Barrett is going to make a Miro board, and then we're going to go through 3 phases. One where people put their ideas down for important research questions. And then the second phase, that might take 3 to 5 minutes, maybe. Second phase of where people cluster those into themes. And then the third phase, which will also probably take 5 minutes, maybe, or 10 minutes. And then the third phase, where we'll discuss it together, and people will vote on what they think the 3 most important themes are. And then they'll have 3 at the end. And then we'll come back, when we come back together, we'll go through each of the breakouts, and each group will say what they think the 3 most important themes are and why they were important.
Sure. Yeah, sounds good.
But we'll just have you as a backup, because I think it depends. Like yesterday we had a big dropout from the keynotes to the brainstorming.
Yeah.
So we'll see what happens. The XR for Health workshop I was just in had 50 people in the workshop. So I'm not sure how much they dropped out to their breakout. They haven't started that yet. They should be starting
Right.
it in about 15 minutes. So we'll see how we go. I anticipate we'll get 40 or so people joining the workshop. And
Yeah.
then, yeah. Okay, so maybe I
Sure,
should
that's
start
fine.
introducing, welcoming some, or getting some people into the, we've only got 3 in the waiting room so far. So let's see if we can get them in. So
Yep.
actually there's Anchoret and Yunhee, and hey, there we go. Hey, Anchoret. Hey, Yunhee.
Hi.
I just wonder if you wanted to, maybe Tobias, you can make them both co-hosts. And hey, Tobias, so we could just check to make sure your slides are working, maybe. Would that be good?
Yep.
We've got a couple of minutes before we start. And so do you want to try first, Anchoret? I think Tobias has made you a co-host.
All right, excellent. Let me shut. Can you see that?
Yeah, perfect. Do you want to go full screen? This is the
Um,
presenter mode, I think now.
Yeah, sure. All good.
Perfect. That's super great. Okay, so
Okay.
maybe we should try Yunhee now. Do you want to see how you're going, Yunhee? Oh, your microphone. Oh, you go.
Yeah,
Perfect.
hi.
Good.
Okay.
Oh, nice. Oops. Okay. Yeah. Now put that full screen as well. We'll see how it goes.
Yep.
Awesome. Well done. Looks good.
Thank you.
And do either of you have any video with sound in it or anything?
No.
Okay,
it's just-
that should be great.
okay.
Good. Okay, so I guess we'll wait. We've got 11 people here now, but most of them are the organizers and the speakers, so we might want to wait a little bit to get some new people coming. I know some of the other workshops are running late, so it may be we may have a delay. Well, we won't want to delay too much, but there may be some delay in getting people in because of the other workshops. Okay, one more person. And thanks for joining from all different times of the world. I guess you must be the latest. Kay, what time is it for you?
It's only 5 o'clock. 5
Oh,
p.m.
okay, great. Yeah, most of the rest of us, as far as I can tell, are from Australia and New Zealand. I don't know where Carolina's joining from. Is it late for you, Carolina?
Yeah, it's like 11 p.m.
11 p.m. Wow. Well, you'll be able to see Kay's talk, and then I'm not sure how much later you want to stay up. So you must be in Europe, is that right?
Yes, I'm from Poland.
Poland. Oh, okay, gosh. Yes, that will be late. Looks like you're wearing the head mount display there for Musics. Is it Musics one?
Yes,
Mm,
these are Music's one.
That's
I
nice.
am not sure which one number, for sure not 300. I guess 300,
Oh,
but
probably.
we are not using them already. We are using newer one.
Yeah. The new ones are nice. Yeah. Okay, so we'll maybe wait 2 or 3 more minutes and we'll get started. We've got a few people coming now into the waiting room. And yeah, if yesterday's any indication, hopefully we'll get around 30 people. Sungchul has audio problem. It sounds okay for us, Sungchul.
Hi everyone, I just got some bad connection maybe, so
Yeah, I think it
I
is.
just want to check out.
No,
Yeah.
it's going good for us here.
Yeah.
And you're joining from, is it New Zealand, Sungchul? Where are you joining from, Sungchul? Oh, you can't hear me. I guess he does have audio problems. Okay. And Nicholas, where are you
I'm
joining
doing-
us from? Oh, there you go,
Uh,
Sancho. Where are you joining from now?
I'm
I'm from
Atlanta, United States.
Oh, okay, good. And Nicholas, where are you joining from?
Germany.
Oh, so it's late for you. So thanks for joining.
Yes, yes.
Yeah. And Connor, where are you joining us from?
Hi there, I'm joining from Scotland.
Oh, wow. So it's also late for you.
Yeah,
A very Scottish name. So that's great. Yeah. And Paul, where are you joining from?
I'm joining from Minnesota in the US.
Oh, okay. Thanks for joining. So most of the people who have the video on, not all everybody, most of them are from New Zealand and Australia, but a few from the US. So that's great. So I guess we'll just wait a couple more minutes and then we'll see if anybody else is joining, and then we'll get started. We may have a smaller workshop. Okay, great. I can probably actually turn off the, yeah, I think I can probably turn off the, maybe I can't. Oh. Okay. So I turned off the waiting room, so probably anybody who wants to can join now. See how it goes. Okay, well, maybe we'll get started. Hopefully more people will join us shortly. I suspect we'll get some flow on from the other workshops that are running late. So let me just share my screen, and then it will work okay. Great, so you should be able to see all of that. So welcome to the Health and Safety in VR and AR workshop. There's a link at the bottom there, which is the web page for the workshop. And also I should remind you there's a Discord channel as well. So if you have questions, you can ask them in Discord. So just to get started, I'd like to give some welcome. So I'm Mark Billinghurst from the University of South Australia and the University of Auckland. And I thought we could go through the organisers who are here to briefly introduce themselves. Unfortunately, Saranga is on holiday right now, so he's not able to join us, but the rest of us are there. So Arindam, do you want to say hello and a bit about yourself?
Yes, sure. Hello, everyone. So I'm Arindam. I'm from the University of Queensland. I'm an honorary lecturer there. Yes, and yeah, that's it from me.
Thanks, Arindam. Barrett?
Hi there. I'm from Monash University. I work in the data visualization and immersive analytics group as a lecturer.
Thanks, Barrett. And Tobias?
Hi everyone, my name is Tobias Lutcher. I'm from the University of South Australia.
Great. And Arash?
Hello, everyone. I'm Arash Manon. I'm a research scientist at Meta Reality Labs in Health and Safety UXRT.
Perfect. And Mingxi?
Hello, this is Mingzi. I'm a research scientist at the CSRO. It's the Australian Research Agency.
Thanks so much. So welcome everybody who's attending. Our numbers are a little bit low right now. We've got 16 in the group, but I'm sure we'll get more once the other workshops start getting out. They're due to finish at 11 o'clock, so some of them are probably running late. So just to give you a bit of context, I think we all know that health and safety in VR and AR is very, very important. You can see this video on the side here of this person who's playing with his friend and almost caused an accident. We've seen companies like Meta who've done a good job with their Guardian system that allows you to mark out your play space, because we've probably all seen pictures on Facebook of the people who've broken their TVs and caused other damage when they've been playing various VR games and boxed the wall and things like that. So there's obviously issues around that. There's issues around simulator sickness, and some studies have shown that up to about 30% of people who try VR experience simulator sickness in one form or other, whether it's mild or serious. And then we've got some people like the person on the bottom right who spent 24 hours in VR. I know there's a lot of concerns about what could be the health and safety issues associated with spending long periods of time in VR and then leaving and trying to drive a car or operate a vehicle. And then even with AR, you've got the picture there of a person who's got an AR app running on their mobile phone. In this case, on the person's phone, a large portion of their real world is now taken up with AR content. And so that could be a big distraction factor. And if I'm starting to play Pokemon Go in the real world and run across the street to chase after a Pokemon character without paying attention, that could also be causing some issues as well. So there's a lot of these issues, and they're going to become more to the fore as the technology becomes more mainstream. As we start selling tens of millions of VR headsets and millions of AR headsets, that's going to be an issue. So in the workshop today, we're hoping to talk about some of that. And in particular, we have a few goals to present some important research topics in health and safety and related topics, to identify some key areas for future research, and then hopefully to build the community a little bit as well and grow the community. So obviously this is a very important area for research, and there's many, many potential topics. And so here's some that we listed from our website. We're not going to be able to address all of those today, but things like methods for identifying health and safety concerns, identifying the research topics, studies on motion sickness, eye strain or other topics, techniques for mitigating hazards in VR and AR, the psychological and physiological underpinnings of the technology, like we talked about before about distraction and cognitive mental load, approaches for limiting distraction, and then evaluation methods for how to measure both objective and subjective measures for bringing health and comfort and safety. So we'll talk about some of those today, and then certainly in the breakout session, we'll have opportunities to talk about those in more detail. So here's the schedule for today. We're very lucky to have Kay Stanley as our first keynote speaker, and I'll introduce her in a second. And then after her, we'll have 3 paper presentations, and Tobias from University of South Australia is going to be running the Q&A session. And then we have a second keynote speech from Richard Yao from Meta, and Mingji's going to introduce him, and he's going to be talking more about physical comfort in VR. And then for the remainder of the workshop, we have a brainstorming activity. We'll break up in breakout into 1 or 2 groups, and as groups we'll brainstorm what we think are the research topics and important research topics, and what areas we should be addressing as a community. And then we'll hopefully close the workshop around 2 o'clock. And for the brainstorming activity, Barrett and Arash will run those, and we may, if we have enough people, we may have a 3rd group with Aaron, and then we'll have a wrap-up session at 2. So, excuse me, without further ado, I'd like to introduce Kay Stanley. So Kay's very well known in the VR and AR research community. She's the CEO and founder of Design Interactive, but before that, she was a professor at the University of Central Florida for a long time, and has over 25 years of research experience in immersive training and human factors, and especially in the simulation space for VR. And because of her outstanding works in these areas, in 2019, she was induced into the National Academy of Engineering. And so she's going to talk to us today about quantifying and comparing the physiological impact of VR versus AR exposure. So I'll stop sharing, and I'll turn the time over to you, Kay.
Thank you, Mark. I appreciate that. And
Great.
thanks for the opportunity to present today. All right. Let's see. Okay, so today I'm going to share our research. Most of the data I'm going to show you is from our labs, and the AR data was recently funded by the Army, and they wanted us to take a deep dive into the physiological impact of AR. There was a general belief that I believe there was a general belief that the AR was simply the benign little counterpart of VR, and our findings could not have surprised us more. So more on that in a bit. But our TPOC within the Army was Dr. Darren Fry, and he likes to say we not only need to determine what an innovative technology like AR and VR can do for us, but we need to understand what they can do to us. And that's what we've found, spent a lot of time trying to uncover, is from a physiological impact, what do these technologies do to us? So why do we care? Because the promise is so great, especially in the enterprise. I know there's a ton from the entertainment side as well, but within the enterprise, especially with regard to Industry 4.0 and censoring up everything and bringing the support and data to the point of need, there's just a tremendous amount of capacity to enhance the expertise of workers and the engagement of workers, increase the productivity and quality and safety. So many benefits, but if we have accessibility limitations, then can everybody actually benefit from the technology? And that is what we've been taking a deep dive into. Most of the data that I'm going to show you is based on over 1,000 participants in VR and over 500 participants in AR. So that's about the size of our databases. So when we compare the two technologies, the bottom line is we feel that there's going to be an accessibility limitation with regard to the capacity to actually sustain exposure with VR, but not with AR. Our dropout rates in VR hovered around an average of 13%. They definitely were longer the longer the exposure duration. Our emetic response rate was consistent with every VR study we ever ran. 1% always vomited. And a lot of people think that with the latest headsets, these problems are going away, but the rates that we have found with the latest generation of VR headsets are comparable to the ones that we used almost 30 years ago. So the bottom line is that VR, we believe, is going to be physiologically self-limiting, and those who are susceptible will oftentimes drop out. And so that will pose an accessibility limitation. We also, though, based on some of the research we've done, believe that it has a whole lot to do with system engineering choices, such as the IPD and content design. So we can design out a lot of the accessibility limitations. From an AR perspective, we don't expect limitations in terms of ability to sustain exposure. In our over 500 participants, we had 0 dropouts. We had 0 emetic response issues. Nobody vomited at all. We didn't have to drive anybody home, which in our VR studies we often do because they're so incapacitated. But on the AR side, we had none of those issues. So we don't expect an accessibility limitation due to physiological impact from a dropout perspective, but there may be one from a safety perspective, and we'll talk more about that in a bit. So what have we discovered to date? So here we're looking first at subjective symptomatology. So we're not talking here about objective measures yet. We'll be talking about that in a little bit. And if you look across the first row there, you'll see legacy systems, which this is, your old systems back, 20 plus years ago. And what we're reporting here is your SSQ. And so you see that the legacy systems, whether male or female, hovered around the 25 to 30 area. And in the lower right-hand side there, we look at the impact of the severity of the symptoms on individuals. And so if you're in that 25 to 30 area range, you're at a medium impact. If you look at the current generation, you see that from the female side, depending on the headset you're using, you can get up into the extreme impact in terms of symptom severity. We split up the current headsets between those where we had an IPD fit and low susceptibility individuals, and then you drop down to be comparable to the legacy systems. But if you take the current headsets and you do not have an IPD fit and you have high susceptibility people, you have those real extreme outcomes. If you look at AR, you're seeing that it really is in that low to moderate range in terms of SSQ. And in a bit, we'll see that that really has very little to do with the gut and more to do with the visual system. So bottom line, whether current generation or legacy systems, definitely your VR systems are placing a heavy physiological impact on the users, and your AR systems are not. We took those symptom profiles and we did our symptoms and did a profile comparing VR to AR. And what you see is with VR, pretty consistently, you have a D is greater than N is greater than O profile, mostly disorientation with quite a bit of nausea and lesser ocular motor. And with our AR profile, we're seeing mostly ocular motor with lesser disorientation and very little nausea. This was one of the most interesting outcomes, in my opinion, from the subjective profile perspective. These are all your individual symptoms on the SSQ. And if you look on the left-hand side there, you see with your VR simulators and your VR experiences that you have a whole collection of symptoms that your users are experiencing. Look how little you have on the AR side. And it really does tend to focus in on that visual fatigue, eye strain, difficulty focusing. So your ocular motor component with very little of anything else. It is having an impact on difficulty concentrating, but beyond that, it's really basically your ocular motor symptoms. Also, if you look at who's experiencing what in terms of the severity sectors, you'll see that with VR, you have a whole lot of people, whether male or female, in the extreme range. With AR, you have more of them in the none to low range. So definitely less of an impact. And even in the extreme range, you're not talking gut activity, you're talking eye strain and visual fatigue and things like that. So we looked at age differences and we did find them with your AR systems. What you're dealing with mostly is young females being severely affected, and with AR, mostly middle-aged females being more affected. This is one of the most interesting and, in my opinion, mind-blowing findings that we had. And that was, I am so used to VR exposure protocols saying, hey, keep the exposure short, especially when you're getting people used to the systems, and have nice long breaks in between exposures. You know, we even, if you're doing it in the military, would recommend 2 to 5 day breaks. We found the exact opposite in AR, and that was that your short duration AR exposures were comparable to your long duration VR exposures in terms of your adverse effects. And in particular, your ocular motor effects in the 20-minute exposures were comparable to your 60-minute exposures in VR. So the exposure duration protocols that we've always promoted within the VR community, we're finding that we don't believe we can use those same kind of protocols in the AR community to foster adaptation. We dove into sex differences because you hear those reported so much of the time. And we see that there's 2 main areas where you have a lot of sex differences, and that is for your non-fit individuals. So if your IP does not fit, IPD that isn't a good fit, then those individuals are going to have some severe issues, and a greater proportion of females have an IPD that doesn't fit because the headsets have been designed around male anthropometrics. And then the other group is the high susceptibility group. So those 2 groups, the latter one, of course, being self-evident, are the ones that really have an impact on who's having the most adverse effects. And so if you look at your current VR headsets with the IPD non-fit, your high susceptibility, you see females really struggling. And the second, the green row there shows an hour post-exposure, and you see those females are still struggling with the current VR headsets. So, the engineering of the headsets today are really difficult for females, many of the different headsets. There are some that are better and some that are worse. In one study, we used one of the headsets that happened to be worse, and I had to drive home the most people I've ever had to drive home. So definitely the current generation have not designed out the issues, but they certainly could if they chose to. Also interesting, if you look at the last column there, the current AR headsets, what you're seeing there is actually that the males are having more difficulty than females, which is interesting. And an hour out, you still see that predominantly male is, the male symptoms are quite a bit more than the females. So that's something that we want to look further into and what might be driving those differences there. But also, if you look at the last three columns, you're looking at the exposure durations. We had 3 40-minute exposures. Actually, if you go all the AR columns, you're basically looking at 1 2-hour exposure, 3 40-minute exposures, and 6 20-minute exposures. And the 6 20-minute exposure is the one that was causing the most issues with regard to adverse physiological impact, which is the exact opposite of what you find in VR. We're going to move on to objective assessments. And this is basically, I'm just going to quickly show you here our protocol. And the main thing being that we do a baseline of hand-eye coordination, visual functioning, and postural stability. And then we look at postural stability post-exposure, and every 15 minutes post-exposure up to an hour out, or with VR up to 2 hours out. So, we're looking basically at the kind of shifts that you might have before and after VR or AR exposure in these 3 different capabilities. If we look at VR 2-hour exposure, what we're seeing is that hand-eye coordination and postural stability 2 hours post-exposure are still, they've never recovered. Your visual system has recovered at about 50% of your exposure duration. And so, long-term adverse physiological impact with a 2-hour VR exposure with current generation VR headset. If you look at AR, this is a 2-hour exposure with adverse effects measured 1 hour out. You see that your postural stability does recover in less than 20 minutes. Your visual system does recover in about 40% of your exposure duration, but your hand-eye coordination never recovers an hour out. The most concerning outcome that we had in terms of AR, if you look at the graph on the left-hand side, is that your hand-eye coordination post-exposure was better with your eyes closed than with your eyes open. So your visual system is very perturbed, and you really have to be careful what you're doing with individuals post-AR exposure, because your hand-eye coordination is off substantially. And so we see this as a potential safety concern that could impact accessibility of AR technology, especially in the enterprise. We looked at gut activity, in particular your EGG and your tachygastria, to take a look at what's going on VR versus AR. The VR data is not ours, that's Denison's data. The AR data in both Magic Leap and HoloLens are ours. The first thing I want to point out is the scale. So your Magic Leap scale is comparable to your VR scale, but your HoloLens scale is actually 3 times the scale of the other 2 in terms of tachygastria power. And so what we found here is that the short at rest, basically the band that you're in is this 12 to 15%. It's the lower, I don't know if you can see my pointer here, but this is the rest here, the lower curve on the VR graph there. That's at what your gut is doing at rest. And you'll see that the Magic Leap, whether you have your 1 2 hour in blue exposure or your 6 20 minutes here, and in the green line, they were at a base comparable to rest. And then your 3 40-minute exposure was comparable within the Magic Leap to your VR curve. If you take a look at HoloLens, however, and again, that 3 40-minute protocol was the one that was the most impactful in the gut. And you'll see that there was quite a lot of activity going on in the gut for that 3 40-minute exposure. But by the time you got out to your 1 2 hour protracted exposure, that had calmed down. So what that says to me is that you have this kind of transition period going on at about the 40-minute mark, where you're getting adjusted to the system. But also what's important to note is within VR, you're feeling this subjectively, you're feeling the gut issues. Within AR, you're really not. There's very little in terms of reporting in the SSQ for the gut activity, except for you do see the Magic Leap a little bit going on there at your 3 40-minute exposure. So, definitely very tolerable, the AR, but there is some gut activity, particularly as you transition, into that 40-minute exposure. If you keep in there longer, it seems to be going away. So what have we learned so far? We've got quite a bit that we understand in terms of VR usage protocols, but not so much that we understand with regard to AR protocols. So what we tend to suggest on the VR side is if you have a low to medium dose VR stimuli, you keep your initial exposures to about 15 to 30 minutes with an intersession interval of 2 to 3 days. If you have a really strong one, then we recommend limiting exposure to less than 10 minutes and having a recovery period of 2 to 5 days. In terms of usage guidance, one of the most important things we recommend is adjustable IPD, and we recommend a range of about 50 to 77 millimeters. Another very important factor is an open periphery, which very few, if any, of the headsets have, but of course the AR headsets are wonderful in that regard. And then we just have some other criteria that we've, in terms of, the airflow and things like that, that we know to do with or VR protocols. With regard to the AR protocols, we just don't have a lot of information at this point. The only thing we definitely would, maintain the IPD range is something that's very important. But we do know that the protracted exposure may cause some dexterity issues, some hand-eye coordination issues that would be of concern, especially if you're using them in the enterprise and you're using them all day, for example, during a workday. So we want to do further research to figure out what is the right protocol. We originally thought the 20-minute exposures with 30-minute breaks in between, just like with VR, would be the perfect protocols for AR. If that was not the case at all. So we think that you may have to maintain exposure in the headset. And I did a lot of looking around to see what might be behaving similarly. And what I did find was there was a study based on astigmatic lenses. So, you're getting a new pair of glasses. What does your doctor tell you to do? Keep them on. And this study in particular looked at 2 4-hour sessions in the eyeglasses and 2 2-hour sessions in the eyeglasses. And only the 2 4-hour session was able to actually achieve the sensory adaptation that you want. So it may be that we had 2-hour sessions protracted in AR. That may not have been enough. In order to get full adaptation, you may need to go out even longer and repeat those long sessions. So we definitely need more research to identify the best way to use AR technology to maintain safety. At this point, the only thing we can say in terms of usage guidelines is don't expect dropouts or emetic responses. People are going to stay in there. They're going to feel fine. Now we've got to figure out how long is safe in terms of exposure duration. If we look into what we know about VR, we definitely do have an evolving science. Never ever take viewpoint control away from the viewer is one of the biggest things we know not to do. We know to avoid visual acceleration, especially and linear or angular, and backwards acceleration is one of the most difficult. We know mismatched IPDs are difficult. We know passive movement. There's so much we know with regard to VR. But what do we need to discover where there's so little we know in terms of the right science for AR? We definitely agree that we want to avoid that mismatched IPD. It's something that will carry over from VR. The only thing that we say in terms of what we may want to do, but I hesitate to say it because it's so different than VR, is we may say that the best thing to do is to adjust your AR headset is just to wear it for a really long period of time to support your sensory systems adapting to the visual display. Definitely, we need more research to make that something that we and other people to take a look at that to make sure that's something we want to be advocating. We also are trying to extend beyond just looking at cyber sickness from a physiological after effects perspective and the SSQ perspective. And so what we've been developing is what we call a model of AR suitability. And so we're looking at individual context receptivity, and that's the degree to which an individual can physiologically tolerate the AR, as well as how well can they process information in and accept the application of it and effectively use that technology. We're looking at task receptivity, definitely differences based on the tasks. The tasks that we were using were mostly in personal space, and there was a lot of hand-eye coordinated activities, and that's likely why it drove those adverse long-term hand-eye coordination disturbances post-exposure. And if you had less of that, would you have less adverse effects post-exposure, and it would be more safe for those types of contexts. And then the environmental receptivity in terms of, the environments you're using these systems in. Definitely there's times when it's, more receptive and less so. And so these are the kind of variables that we're looking into with regard to context receptivity in terms of the human, the physiological capacity to cope with the exposure, your high immersive tendencies, your spatial ability. Tasks, we're seeing that, those that require the embodied, spatialized, contextualized knowledge acquisition and skills practice are really suitable for AR, but may lead to the safety concerns. And then, we look at factors like ambient lighting, temperature, stability, and noise. We're also looking at the system efficacy factors, the optics, the display capabilities, the graphics quality. Definitely all three of those are going to make a system more or less suitable to use, as well as contribute to the adverse physiological impact. And the type of factors we're looking at in terms of AR system efficacy are wearability, optics, display capabilities, graphics, and the authoring tool itself. And so we have this AR suitability model that we're developing and basically trying to look at the factors that will make a solution more or less receptive to the application of AR technology. And basically overall, we're trying to develop an AR design science where we look at the physiological impacts in terms of maladaptation. We look at how we best want to use it in terms of training and operational support. And we're looking at how best to design it to increase the efficacy of the systems themselves. And so there's a lot that we still need to know in terms of physiological adaptation. Definitely that optimal usage protocol is an unknown at this point, and we can't use our VR guidelines to guide what we do in the AR because it's behaving so differently. And so we may need to do long-term duration exposures, and or we may need to do intermittent exposures with much shorter breaks. The breaks that we used were 30 minutes because that was suitable for VR technology. It was not suitable for AR technology. And yeah, so we have a ton of publications, and I'm going to turn it over to questions.
Great, Kay. Thanks so much for that presentation. That was really amazing. Maybe if you stop your sharing your screen now so we can see your face. And then if you've got questions, please feel free to put them into the chat on Zoom, or also on the Discord channel. I'm watching that as well. I had one question. So it seems like the take-home message is that we should be using VR in short chunks of time, maybe 15, 20 minutes or so. We can use AR in longer periods of time without necessarily having adverse effects apart from hand-eye coordination. What do you think is the main difference in the technologies that's causing that difference in the cyber sickness effects? Obviously it's the immersion part, but I wonder if you can talk about that a bit more.
Yeah, I mean, definitely with AR, you have the advantage of you have continual rest frames, right? Your real world rest frames. And we're seeing that there isn't the gut element that we see all the time in AR or VR, which has been, a stark difference. And I think it's because you can always calibrate yourself to the real world. It's always there as an anchor. Whereas with VR, we know we have that terrible visual vestibular mismatch that there's not a lot we can do about. And so we think that's what's driving the profound difference in the gut activity. In terms of the hand-eye coordination adverse after effects in AR, we were doing a whole lot of activity in personal space. And it was, 2 hours of hand-eye coordinated activity. It was medical tasks, and you were, applying tourniquets, and you were, doing different types of activities on a mannequin for 2 hours. And it required a lot of hand-eye coordination. And you have the visual distortions in the headset. And so if you're doing, as you would in any kind of organization, likely, a lot of the tasks that we intend AR for are tasks that, maintenance and operational support, where you're doing a lot of hand-eye coordinated activities. And we should anticipate, because of that, we're going to be getting those adverse hand-eye coordinated maladaptations for long periods of time after, because you've got the distortions and you're working in near space, personal space, and it's driving those changes. Whereas with VR, you probably didn't have as much hand-eye coordinated problems, because most of the time you weren't, I guess if you had haptic gloves, you were doing it, but those led to other problems. But you mostly were experiencing something, running through it, not doing a whole lot of hand-eye coordinated, fine-tuned activities.
That's really great. So if anybody else has any other questions, please put them in the chat or in the Discord channel. So a couple have started appearing. Ingrid says that she found interesting that postural stability recovered for AR but not for VR. Do you have any idea why this might be the case?
Yeah, I mean, you have that profound visual vestibular mismatch in VR, and posture is all about the vestibular system. So you're impacting that aspect of physiology because you're driving that really profound difference. You think you're moving around, but you're really not. You're sitting there stationary, and we know the poison theory. When you have those kind of sensory conflicts, your body thinks you're poisoned, and it really doesn't like it. And so your vestibular system is very perturbed in VR, but it's not in AR. You always have the real world anchors in AR.
So I had a kind of related question. So you can imagine the Paul Milgram's continuum where you go from the real world to AR through to VR. So I imagine in your research you've kind of explored one type of or a few types of VR displays, a few types of AR displays, but I'm not sure. But I imagine you could also imagine some displays that would support that continuum, where you've got displays that could show either VR or AR content, like the new Vario display, which is a video pass-through headset that can go fully immersive and show just VR content, or it can show camera view of the real world and show just AR content. So do you think you'll have there's some relationship between the amount of the real world you're seeing and those vestibular or those sim sickness effects you're having, where at one end you've got VR where you might feel sick after 15 minutes, at the other end you've got AR where you can spend hours in the display, but maybe if you've got a system where 60% of your real world is replaced by graphics and you're kind of somewhere in between. So I'm not sure if you've thought about that at all.
Yeah, the actually content that we had, we did it in the HoloLens, but we were doing VR in the AR, not all the time. But for example, when you would start a scenario and someone was approaching a casualty, the whole surround was virtual and it was a battlefield. And so we were doing VR in the AR headset. And then once you got to your casualty, and then there was a portal that would open up and you could start to do your hand-eye coordination activities on the mannequin. And then, you had a lot of real world references at that point. So that was a mix of VR and AR and real world, all three together.
And we've got another question here or comment from Nicholas, and he says about the hand-eye coordination that seems to be going on. Can you talk a bit about in what type of task AR environments this appears and how these are different to the same task in the real world regarding the perceived coordinate system?
Yes, so basically with regard to the tasks we were doing what we call the March algorithm. So you're giving care to a mannequin and you're addressing massive hemorrhage by putting on a tourniquet, and you're opening up the airways, you're looking at respiration, and you're looking at circulation and head injuries. So you're doing these different activities based on this March algorithm on a mannequin. And so a lot of hand-eye coordinated activities, needle decompression, things like that. That's a very fine, motor skill in terms of have to put that needle in just the right place at just the right rib, and so some of them are real fine motor skills, and then your tourniquet and putting out any kind of bandages or things like that aren't as fine-tuned. But we had a mix of real fine motor skills and other in personal space hand-eye coordinated activities. So those are the kind of tasks that we did.
Right, and then Uni asks what kind of AR VR content we use in your study. I guess you've talked about this a little bit. Did you have a standard VR AR content, or do you adopt commercial content which can be found in the market?
We built it with Unity, so we built our own content.
And I had a related question. It seems like the HoloLens 1 performed worse than the Meta display in terms of recovery. And is that because of the ergonomics, do you think, or is there other factors? I mean, they have a similar field of view in terms of AR, but the HoloLens 1 is a bit heavier on the head and has other ergonomic factors that may not be as good as the Meta. So I wasn't quite sure
Yeah, we looked at the Magic Leap and the HoloLens.
Oh, sorry, the
one.
Magic Leap, not the Meta. So
Yeah,
Magic Leap,
and
yeah.
so we are now looking at HoloLens too, but at the time we did these studies that it was not available yet, unfortunately. In terms of the gut activity, that's the main place we saw a difference in the Magic Leap. And so perhaps you're finding some benefit to the dual depth planes. We haven't found it in terms of performance. This talk didn't at all address performance, but we haven't found any performance benefits in the Magic Leap. And yet maybe there's some benefit to gut activities. I mean, that's the one thing that we saw is, and that's the only benefit and we've looked at a lot of tasks and a lot of factors, and we really haven't found a lot. But again, it might be how Magic Leap has implemented the multiple depth planes, which it definitely didn't fulfill the promise that they originally, had, which it wasn't infinite, but it was definitely more than 2. And they have algorithms on how to pick which one you use. So, it's probably the implementation of it.
Great. Well, thank you. We'll stop there. And if anybody has any other questions, feel free to ask them in the chat. And I imagine that Kay, we have to stay on for a little while before it gets too late for her, and also in the Discord channel as well. So let me just share my screen briefly again, and we're now going to turn over to the paper presentations, and Tobias from University of South Australia is going to moderate those. So we have Ankrit, Cheryl and Uni are going to provide 3 presentations. They'll each be around 15 minutes or less each, and then at the end of this time we'll have a 10 to 15 minute Q&A session after that. So I'll turn the time over to you, Tobias, and I'm looking forward to those presentations.
Yes, thank you, Mark, and thank you, Kay, for this interesting presentation. I actually don't have much to add to what Mark just said. I'm really excited to see facilitate 3 paper presentations. As Mark said, they go for around 15 minutes, and then at the very end, we have a Q&A session. With that, I think I hand over to Ankrit Spark, who will present the paper, Getting the Most Out of Virtual Reality, Evaluating Short Breaks to Reduce Cyber Sickness and Cognitive After Effects. Thank you, Andre.
Thank you very much. So let me just share my screen. All right, can you see that? Yep, great. Thank you. So I'm not sure how to follow that amazing talk by Stani, sorry. And she did an amazing talk, and she even covered some of the stuff that I'd be talking about today. But hopefully there might be some interesting questions or something to add from my presentation. So I'm going to be talking about short breaks. So many organizations are using virtual reality for training, and VR has amazing potential to train skills that might otherwise be difficult to train. But there's still a lot of people that experience negative symptoms of cyber sickness and cognitive after effects that may hinder the benefits of training. In a recent systematic review and meta-analysis on self-report VR sickness, there's estimates that about 15% of people will drop out of virtual reality studies. So those are very similar numbers to what Kay mentioned at the moment in her presentation. But even the people that still continue on to do those studies, there will still be a high level of virtual reality sickness that will be experienced. So the numbers are sort of quite high in terms of who's actually getting really sick. And notably that the length of virtual reality exposure also has an impact on VR sickness. So that is, the longer you're spending time in virtual reality, the more sick that people will feel. And there's various design choices that developers might use to integrate into their systems to help reduce sickness. So for example, including rest frames and different locomotion techniques, visual blurring, and things like that. But there's also strategies that have been suggested to be helpful that can be implemented by the user, and that includes taking short breaks. Device manufacturers particularly recommend this in their health and safety guidelines to take regular short breaks to help reduce symptoms. So here are some examples of from device manufacturers, from their guidelines on what they say about taking breaks. So many recommend taking 10 to 15-minute breaks every 30 minutes. Some manufacturers are less specific and they suggest just avoiding long, prolonged exposures and that users should take regular breaks, but they don't specify how long is a prolonged exposure and how long their break should be. Most of the guidelines also list different possible symptoms of cyber sickness, such as dizziness and nausea, but they'll also include cognitive effects as well. But a key assumption that is made is that the user will be able to judge when they're experiencing symptoms and when their symptoms will disappear after a break. Although symptoms such as nausea and dizziness might be clear to the user, there might be other symptoms such as changes to hand-eye coordination, changes to reaction times, visual disturbances, and things that might be a lot more difficult to judge. So to date, I haven't seen a lot of studies that have compared cognitive after effects and cyber sickness between long exposures and exposures that have breaks. There has been some research in other areas outside of VR that suggest taking short breaks might be beneficial for learning. So if we think about that in the context of virtual reality training, short breaks can have, they can help with cognitive performance. But there hasn't been a lot looking at whether that actually helps with cyber sickness as well. And given the importance of trying to get the most out of virtual reality training, we wanted to investigate the impact of breaks on VR sickness, perceived workload, reaction times, and spatial learning. So to address these aims, we used a within subject design to compare a long continuous 50-minute exposure with an interrupted 15-minute exposure that had 4 10-minute breaks in it. So we had 25 participants and one data point was missing. So we excluded one person. We used the HTC Vive Pro and we used the game Space Pirate Trainer. We chose the game Space Pirate Trainer because at the time it was the most popular game. And we wanted our participants to be engaged for the full experimental time. We also didn't want to purposely induce cyber sickness. So we chose Space Pirate Trainer because it was rated as comfortable in the Oculus Store. And this was something that people would be engaged with. In the game, that participants, they would be shooting waves of flying targets, and the aim would be to reach a high score. So fairly sort of linear kind of gameplay. We also wanted our participants to somewhat represent a typical training or gaming session, whereby people would either play for long periods of time or take regular breaks as recommended in the guidelines. So this was our procedure. So if you look at figure 2, what we did is we had these 2 different conditions. So in the first one, participants did VR for 50 minutes. And we also had a break condition where participants did VR for 50 minutes as well, but with 4 10-minute breaks. And participants did both of these conditions in a counterbalanced order on different days. So there was a minimum of 24 hours between conditions, but for a lot of participants, it was probably more like 2 days at least between the 2 conditions that they did. Cyber sickness workload and cognition were measured at different time points. So if you look at the image again, that we have these time points where we took these different measures. So we had one at baseline, there was an immediate test after VR, and then there was a late test 40 minutes later. The test that we used was a reaction time task from the Cambridge Cognition package. This was a 5-choice reaction time task where participants, so we used it was on an iPad, and participants would, if you look at the image over there on figure 3, participants would keep their finger on the button at the bottom, and then a yellow circle would appear in any one of the 5 different locations randomly. And participants had to respond as quickly as possible to those 5 different locations. And because it was sort of designed in this way, it's also possible to differentiate between decision times, which is more sort of attention to cognitive aspect, and motor speeds of how long it actually took a person to respond to the target. So actually physically move their finger from one to the next. We also used the SSQ, so that the Simulated Sickness Questionnaire by Kennedy, that had 3 different subscales of nausea, disorientation, and visual disturbances. We used the NASA TLX task on the iPad, and this participants would rate their workload on mental, physical, temporal demands, as well as perceived performance, effort, and frustration. And we also had the sort of a spatial learning task. So if you look at the 2 images there on the bottom, in the spatial learning task, this was called the Paired Associated Learning Task, PAL. And in this task, there would be a learning phase where a pattern would appear, and under all these gray boxes, and they would be revealed one at a time. And participants would need to remember each of those patterns. And then there would be a recall phase where it would show a random pattern, and participants would need to remember specifically when that pattern appeared. So we wanted to look at the effect of VR on subsequent learning. And the way in which these tasks were presented was at baseline, there was the reaction time task and the SSQ. Immediately afterwards, there was the SSQ, the NASA load task. There was reaction times measured as well. And in the late test, there was the SSQ reaction times and then the learning task at the end. And this was specifically to compare the breaks versus the continuous condition. So just sort of to go through the main findings, and I'll go a little bit more into detail in some of the other findings. But essentially, we found that there was a main effect of time points. So when we actually took these different measures, with higher sickness scores being reported immediately after VR compared to the baseline and late measures. There was no effect of exposure conditions, and there was no interactions either. So there was no difference between whether participants took breaks or didn't take breaks. But there was definitely an effect immediately afterwards. And a score of 20 is, according to Kennedy's configural scoring paper, is still relatively high symptoms considered to be serious. And we also found very similar patterns as well for the different subscales of nausea, disorientation, and visual disturbances, where we found that immediate effect, but there was no effect of exposure, and there was no effect of exposure conditions. And I think that this suggests that essentially that 10-minute breaks actually had very little impact on virtual reality sickness. So the fact that there wasn't any difference between the 2 conditions, and people still experienced a high level of symptoms immediately afterwards, suggests that 10 minutes really did nothing much. Interestingly, the symptoms returned to baseline levels at the late time point. This was 40 minutes after VR. And this suggests that actually taking longer breaks might be more beneficial than taking shorter breaks. If we look at the other measure of workload, so sort of what impact do breaks have on workload? So if we look at all the different elements that were measured there, that there was no difference between exposures except for performance. So participants suggested that repeated breaks as having a negative impact on their perceived performance. So this makes a lot of sort of common sense that, if you're sort of in there and you feel like you're in the flow, and then you have to come out after 10 minutes and then go back in and come out and go back in, that you might perceive that this is having a negative impact on your performance. You want to just stay in there, just go longer and sort of, you know, achieve your high score. Theoretically, breaks should improve cognitive performance, as it's helped in other contexts outside of VR. But I guess when it comes to VR, there are additional factors that would be affecting cognition and workload, especially with repeated adaptation between VR and the real world. This might have added to the cognitive demands and potentially negated any positive effects that breaks may have had. What impact do breaks have on cognitive performance? So different elements of cognitive performance, if we think about training, such as reaction time, mental load, and learning outcomes, all very important. But there's a lot of inconsistent findings in the literature about things such as reaction time. So whether VR increases or decreases reaction times, there's a lot of inconsistent findings reported in the literature. You know, it might depend on content and a whole bunch of other different factors. Generally, reaction times are measured before and after VR, but not after breaks. But sort of in our study, we didn't find that taking breaks really had any impact on reaction times. And there were also no longer sort of lasting effects of VR on reaction times either. Can breaks affect subsequent learning? So there is a benefit to looking at subsequent learning, particularly in the context of training as well. After effects of cyber sickness, such as fatigue and disorientation, might continue to affect the user after training. So if, for example, a person goes into VR, they do some training, and then they want to come out and perform that same task in the real world, this could potentially impact on any subsequent learning. So that was sort of one of the motivations that we had for specifically looking and comparing breaks versus the long continuous exposure. And we didn't find that there was any concerning effects on subsequent learning, no differences between the two groups there either. So what implications are there for training? So because there was no observable differences between the continuous and break condition, it sort of suggests that this is an important factor to consider when trying to implement training with organizations, because this including breaks will increase the time that users spend on the task, which would add to the logistics and costs of training. So for example, if an organization wanted to train 50 people with 4 10-minute breaks scheduled into their training, this would mean that the overall training would be 33 hours longer than if they didn't have breaks at all, which I think is a significant cost to an organization that wants to implement training. And so I think it's really important to look at the optimal schedule for training, how long breaks should be, if there are going to be breaks included, where they should be placed, and how long exposures should be before people start experiencing very serious effects. So there's a lot of practical implications for this. Just some sort of final remarks. So although device manufacturers recommend taking breaks, there's very limited evidence to support this recommendation. We didn't find this in our study either. Rather, we found that longer rest periods actually perhaps more beneficial for both lengthy continuous exposures as well as for after effects that might be accrued after repeated exposures. There's more, I guess, research needed to be sort of investigated in this space. And there's also many ways in which this study could have been designed to evaluate breaks. We just sort of chose one way of looking at it. But I think, caution needs to be sort of taken when promoting breaks to reduce cyber sickness, particularly if people feel like, yeah, this is going to reduce my cyber sickness, I'm just going to take these breaks, and really actually having very little impact on this cyber sickness. And sort of over time, that their cyber sickness will just keep on increasing and getting worse if they keep on going back in and out of VR. So I think it's important that there's more sort of research that is done in this area to try to understand what is the optimal exposure durations and sort of how long breaks should be. Thank you.
Excellent. Thank you very much, Andre. That was very interesting. We have the Q&A at the end after like the three speakers gave their presentations. But if you already can think of questions, feel free to put them into the chat now. Oh, Richard, do you have a question? No. Okay. So in that case, we move to Cheryl Loin from the University of Hong Kong. Hi, Cheryl.
Hi.
You should be able to share your slides.
Sure.
Cheryl will be talking about human factors related to cyber sickness tolerance in virtual environments.
May I start now?
Mm-hmm.
I'll start now. So hi everyone, my name is Cheryl, and today I'm going to discuss about the different individual factors that may have influences on the tolerance level of cyber sickness when being exposed to a virtual environment, and how the factors will affect cyber sickness discomfort. So we define cyber sickness as the sickness or discomfort that arises during or after an exposure to virtual reality similar to motion sickness. One may experience symptoms like nausea, stomach awareness, dizziness, etc. With the rising popularity of VR systems, cyber sickness is one of the major health risks that come along with the VR usage. Research suggested that around 60 to 95% of users experience some sort of cyber sickness symptoms during and after their exposure to VR. Even worse, around 6 to 13% of users halted the exposure prematurely. So in order to ensure safe VR use in the future, it is essential to understand which human factors will affect one's susceptibility to cyber sickness. This enables us to identify potential risk factors during use of VR, hence establish health and safety guidelines. In this paper, we investigated 3 factors that have been suggested to affect cyber sickness discomfort by previous research, which is the sleep quality, pain sensitivity, and spatial ability. So first off, lack of sleep has been suggested to increase cyber sickness severity. In Kaplan's study, the researchers found that subjects with shorter sleeping hours experience more cyber sickness discomfort when being exposed to a nauseatic condition. Their rate of adaptation to sickness over repeated exposure were also slower than the group of subjects with longer sleeping hours. Next, in hemorrhage study about pain sensitivity, we measured cyber sickness levels in a group of adults while playing a nauseatic video on a projector and asked the female participants to rate their pain levels in general during menstruation. And results suggested that females with higher perceived menstrual pain levels tended to have a higher cyber sickness susceptibility compared to male subjects and female subjects that have lower pain rating. And for our third factor, spatial ability, a research by Smith found that by training participants and improving their spatial ability, the cyber sickness severity had reduced by around 55% after being exposed to a nauseatic route on a driving simulator. Therefore, we hypothesized that a person with higher sleep quality, higher spatial ability, and higher pain threshold, which means less sensitive to pain, would experience less severe cyber sickness. To examine these factors, we utilized several assessment tools. For sleep quality, we measured the participants' sleep quality by using a specific sleep questionnaire called the Richards-Campbell Sleep Questionnaire, or CSQ, to measure the participants' sleep quality at night prior to the VR exposure in experiment. And for pain sensitivity, we measured the pressure pain threshold of the participants with the 2 here at the right corner called the digital pain algometer. So we applied the pressure, the algometer, on the participant's shoulder area at a consistent rate until the participants asked to stop when they feel a noticeable pain sensation. The numbers shown on the algometer will be their pressure pain threshold. And for spatial ability, we prepared a task called mental rotation task. And it is a task that includes some 3D figures of blocks with different configurations. And the participants were instructed to find the 2 matching figures that have the same structure but with different orientations, such as the blocks that's shown in the slide, on the slide. And for cyber sickness measurements, we use the MSSQ Motion Sickness Susceptibility Questionnaire to measure the participants' susceptibility of cyber sickness before the VR exposure. And we also use the Simulator Sickness Questionnaire for measuring the severity of the symptoms of the participant. And for we also use the misery scale, and it was recorded by the experimenter for measuring the instant feeling, like how the participants feel right at the moment when they're exposed to the VR at a certain time. For example, when they feel kind of dizzy, when I ask them like, how do you feel at that moment? And then they feel slightly dizzy, a score of 2 will be given. Or if they feel like no problem at all, no symptoms at all, then a score of 0 will be given. Another main variable here was the cyber sickness tolerance, and we measured by timing the duration participants were able to stay in a virtual environment before experiencing any symptoms. And lastly, we also measured the participants' balance as well. So our study recruited 26 adults, all with normal visions, no any physiological impairments, and had no prior participation in any experiments related to the cyber sickness. The experiment lasted for around 30 minutes, including a 5-minute VR exposure, and a room tour was shown to the participants through a head-mounted display. So first, after the briefing of the experiment, the participants were asked to fill in several questionnaires, including their background information, their current conditions, like how well they slept last night, asking about their sleep quality, using the RCSQ sleep questionnaire, and then asking how are they experiencing any symptoms with the SSQ, how are they feeling currently, and we also asked about their cyber sickness susceptibility with the MSSQ. And next, they were asked to work on the mental rotation task for the spatial ability measurement, and also the pain test was done for the pain sensitivity measurement. And right before the VR exposure, we measured their postural activity for baseline record. And then we asked them to stay on the balance board for the balance measurement during the VR later. And then we assist them to wear on the head mount. And then we'll proceed to a 5-minute exposure. And within the 5 minutes, they will be seeing a virtual room tour. And we played a video with a fixed moving route. And they were given a letter searching task as well. There would be like letters randomly popping up in the video so that to encourage them to move their heads while their body don't move in order to generate sickness. Misery scale and tolerance time were recorded during the progress as well. And subjects were instructed to notify the experimenters that if they experience any sickness symptoms, however mild, the experiment will be halted. And at the final stage, they were instructed to fill in the SSQ again, and a final balance measurement would be taken. To test whether sleep quality affects cyber sickness severity, we assessed participants' perspective of their sleep regarding the night prior to the virtual experience using the RCSQ. We used tolerance duration in the virtual environment as a measure of the severity of cyber sickness experience. And our results showed that tolerance duration and sleep quality scores were positively correlated. This suggested that participants with better sleep quality had better cyber sickness tolerance. And for our next variable, pain sensitivity, we assessed pressure pain threshold on the subject's shoulder. and we classified them into two groups: the low pain threshold group and the high pain threshold group. And we cut off the two groups with by using the cutting off the low threshold group by a level of 1 standard deviation of our data. And our results showed that the participants with lower pressure pain threshold had slightly lower cyber sickness tolerance, meaning with a shorter duration in virtual environment. And by comparing pain threshold with the MSSQ scores, we also found that low threshold group had higher cyber sickness susceptibility. And furthermore, by comparing pressure pain threshold with the SSQ scores, we found that low threshold group reported more severe cyber sickness symptoms as they had higher SSQ scores. And next, we found a positive correlation between MSSQ scores and SSQ scores, meaning participants with higher cyber sickness susceptibility reported more cyber sickness symptoms. And higher susceptibility was also found to be related to lower cyber sickness tolerance, but just slightly since the results were insignificant. And lastly, for our third factor, spatial ability, we found all correlations between mental rotation task scores and the tolerance duration, SSQ or MSSQ, were insignificant. And same goes to the postural activity. The correlations were insignificant. So at the beginning, we hypothesized that a person with higher sleep quality, higher spatial ability, and higher pain threshold would experience less severe cyber sickness. And our study results did support some of the past research by finding that participants with better sleep quality had better cyber sickness tolerance, and that participants with lower pain sensitivity experienced less severe cyber sickness. However, we did not find any evidence to suggest relationships between spatial ability and cyber sickness discomfort. Future research can dig further into these factors and investigate specific target groups that are greatly impacted by the factors mentioned. For example, people who work at night shifts or experience sleeping difficulties may have more severe symptoms with that poor sleep quality. And it's also noteworthy for VR programmers and designers that when they're designing any VR applications, they could pay attention for particular users that are prone to have severe symptoms, so that the risk of VR usage can be lessened, especially to those who utilize VR for clinical or rehab uses, such as therapy for certain patients. And that's the end of the talk. Thank you very much.
Thank you very much, Cheryl, for this interesting talk. I've seen a few questions have come through for Ankri already. Hopefully we get also a few questions for like Cheryl that we can then look at in the Q&A. The final paper is by Uni Chang from the Korea Institute of Science and Technology. She will be talking about identifying physiological correlates of cyber sickness in HMD-based virtual reality. Uni, do you want to share your screen?
Sure. Okay. Can you see my screen?
Yeah, perfect.
Okay. Okay, hi everyone, I'm Uni, and today I'm going to present identifying physiological correlates of cyber sickness in HMD-based VR. Okay, I got my degree in 2019, and I have researched cyber sickness in terms of psychological perspective using physiological signals. So as we all know, according to the sensory conflict theory, cyber sickness is caused by the sensory mismatch between the visual and vestibular input. Personally, I think cyber sickness research can be categorized into three major topics. One is which factors are associated with the symptom. And the second is how we can measure the symptom. And lastly, what we can do to reduce cyber sickness. And my recent studies have particularly focused on the measures of the symptom. So the easiest way to measure cyber sickness would be asking participants. So traditionally, we use questionnaires or verbal reports to measure the subjective severity of the symptom. Or we can render this kind of questions in the VR contents directly. Subjective measures are easy and intuitive, but there can be great variance between the participants. So we have tried to find an objective way to quantify the severity of cyber sickness. And according to my review, postural sway is the most widely adopted measures. When users experience cyber sickness, this uncomfortable body state can induce physiological changes as well. Compared to the subjective measures, physiological signals can detect cyber sickness instantly, but the weak point is we need to attach extra devices or the signal recording. So fortunately, I had some opportunity to adopt various physiological signals for monitoring the negative symptoms. And some of them are successfully detect the symptoms, but some are not. In particular, well, I couldn't find any significant differences in autonomic nervous system's responses according to the cyber sickness, but I found differences in brain waves. So these results motivated me to consider interoceptive perception during cyber sickness. So there's increasing evidence that our brain processes not only sensory motor signals, but also interoceptive signals such as like heartbeat or respiration during the self-consciousness or perceptual experience. And also, though the cyber sickness is definitely uncomfortable and negative feelings to the users, but it is not a like life-threatening to the users. So it might be difficult to change one's heartbeats or respiration dramatically and instantly during the short period of time. However, their transient changes can be reflected in the cortical process. And another point is most previous research in cyber sickness related EEG has performed frequency domain analysis. Of course, this analysis is well established and provides insights into the phenomenon, but it can lose temporal information of EEG during cyber sickness. So based on these motivations, I recently published an article using a heartbeat evoked potential analysis. Okay, so you can guess by its name, this analysis is a sort of event-related potential analysis, which defines a specific ECG peak as an event. So the left side of diagram shows a typical ERP experiment that uses like sensory stimulus as an event. for example, visual or auditory stimulus. But on the other hand, HEP analysis computes cortical processing of cardiac signals. So while a person is experiencing the VR contents, his or her EEG and ECG are recorded simultaneously. So when we zoom in on the ECG, there are two sharp positive peaks, which called R peak or T peaks. And depending on the research purpose, we can define one of these peaks as an event. So in my case, my EEG data was epoched between -200 milliseconds and 600 milliseconds relative to the R peak onset. And after I epoching the signals and then averaging them to compute HEP amplitude. So this is the detailed procedure for signal processing. So most parts are well defined, typical process for EEG analysis, but the most time-consuming point is to find out the R peaks of individuals, because people have slightly different time range between those two peaks. So, I assume that there would be a difference in HEP amplitude depending on the level of cybersickness. So the previous works usually adopted more than 2 VR contents that had a unique scenario to induce different severity of cybersickness. For example, one is like peaceful, slow, and not much movement contents to induce lower level of cybersickness, but the other is dynamically moving scenario that induce higher severity. But I think this approach cannot clarify that whether the cortical change are originated from the processing of different visual information or the level of discomfort. So I used a VR roller coaster, which has 2 opposite orientation to such as this is the applied condition VR roller coaster, and this is the inverted condition. So this is meant to control the total amount of sensory information, but induced varying degree of cybersickness. So that is the visual input from each VR was identical, but participants showed less cybersickness when they watched an inverted scene. Oops. Okay, so this is the picture of the experiment. I used BioPack for the ECG recording and NeuroScan for the brain signal. And the most important part of this experimental setup is to align 2 signals synchronously. So using a light sensor, I could record the exact onset point to both ECG and EEG signals. And I recruited 20 participants, and as I mentioned, there was difference in VR contents orientation, and they repeated the same VR contents to adapt it to those VR experience. And I measured SSQ and FMS for the subjective measures, and ECG and EEG were recorded. So this is the result of behavioral data. So I found that our SSQ score except oculomotor index were reduced due to the repetition, and SSQ score for nausea symptoms showed a significant difference according to the orientation, which means people show less nausea symptoms when they watched inverted VR roller coaster. And this is the overall topography for 8 representative cortical clusters for HEP. So during the time window of 300 to 450 milliseconds from our peak onset, each cluster shows unique electric potential reflecting the heartbeat onset. But to be specific, my target clusters were frontal central area and parietal area, and the results showed that there was a significant suppression in HEP amplitude at the frontal central area when participants watched on upright condition. And also, I found a significant negative correlation between the SSQD score and frontal central HEP amplitude, which means person who show a higher SSQ disorientation score showed a lower amplitude at the frontal central area. And this research might indicate a possibility to use this HEP amplitude as detecting cybersickness. Well, but my biggest concern about the objective measures is, can we apply these methods to end user in the real world? So due to the technical limitations, I had to put so many electrodes onto the participants, and it was pretty cumbersome to both the experimenter and the participants. So my recent experiment adopted Quest 2 for wireless VR experience and attached 4 rigid body sensors to record upper body sway. So this setup was less clumsy and allowed the participants to enjoy the VR content relatively more freely, and they can move their body less restrained. So I just finished collecting this data, so I have to delve into to analyze it and hope to find some significant results for detecting the cybersickness. And also, I think we need to expand the context of cybersickness research from games to various VR/AR interactions, such as remote collaborations. So due to the COVID, VR/AR will be applied in various scenarios within multiple users. So I'm sure that it will be more getting important how to reliably measure and detect one's discomfort. And I hope we can share our experience of measuring cybersickness in this workshop. Thank you.
Fantastic. Thank you very much, Uni. Thank you, Ankre, Cheryl, and Oini for these great talks, and I'm excited to move on to the Q&A session. So please keep putting your questions into the chat, and maybe we start with the first question that was put in by Kay. Kay, do you want to ask a question directly?
Sure. So we've done a lot of work, and this is, you have to help me to pronounce your name. How do you say it?
Ankre.
Ankre.
Yeah.
So beautiful name. So we've done a lot of VR research, as have others, and found that the breaks do support reduced cyber sickness, and our findings were profound differences. So we found, without the breaks that you might be at like, say, a 40 on your SSQ immediately after, and you might be at maybe a 12 if you took a break or two. Our breaks in VR were typically about 15 minutes. And now, more in line with what you did, I do know of the Moss and Muth study where they did 1 minute breaks, and those 1 minute breaks did not help at all. You had 10-minute breaks. So I'm wondering your thoughts on, ours were really profoundly helpful. Moss at 1 minute, you can simply say 1 minute wasn't enough, but yours are 10 minutes. So what are your thoughts?
I think that's a really, really interesting. I didn't know about your study. I know about the Moss and Muth paper. And I think they had 5 2-minute exposures with 1 minute breaks in between. I think that was how they designed their study. And then they also took post measures 5 minutes after and 10 minutes after as well. So I think there was also like a 15-minute period at the end. And they actually found also a reduction in symptoms when they had those post measures. So they might have not found it for the 1 minute, but 10 minutes, and then they had those post measures afterwards. After the 10-minute exposure seems to really reduce symptoms. But with our study, we had repeated in and out of VR with 10-minute exposures, 10-minute breaks. So I do wonder if potentially there might have been some, maybe 10 minutes wasn't enough, and those residual effects might have accumulated over time. And at the end of it, you get a very equivalent scores to one long 50-minute exposure. It's interesting that you had a 2-hour-long exposure with 15-minute breaks, and you found that to be helpful. I'm curious about the spacing of breaks and that. Do you know how many breaks that you guys had?
We're going back like 5 years. I'm trying to go on to other questions. I'll find the report. It was commercial report, so we could not publish it. That's why it's not published. But I'm going to go look at that right now.
But I mean, I think that's a very, very interesting idea to point out, because there are these subtle differences. You don't think 10 and 50 minutes is that much difference, but it seems as though there is actually, in your case, there was this massive reduction in symptoms from 40 down to 12, which is super interesting. And 2 hours is a really long time to expose people to VR as well.
Perhaps related, or like explaining some of the differences is like a question James asked about the individual differences. I don't know, actually, do you want to talk about the individual differences we found in that study?
Just so let me tell you that we had breaks after, we had 3 groups. One was a no break, one was breaks after 30 minutes of exposure with total exposure, 2 hours for everything. So, and then another group was breaks after 1 hour of exposure. So 30 to 60 minutes of exposure before a break.
Okay, wow. And then so you had a few there, and then the 50 minutes would have been good. Okay, interesting. Sorry, Toby, I didn't hear what you said. You cut out and I missed what you said.
Oh, my apologies. Yeah, I just wanted to move on to the next question by James about whether you observed major individual differences.
I mean, I think, when you do sort of look at cyber sickness, it's always going to be somebody that experiences symptoms a lot more than others, and some people that there's no effect, but there weren't any major individual differences that we could tell that was really driving the effect. We did sort of look to see if there was any one particular person or 2 people that, changed the results, but we didn't see anything there. So, we just thought, okay, we just keep everybody in there. And we didn't find any of those individual differences, but it's also possible that because we only had 25 participants, that maybe we didn't have a broad range of people in there with, various different levels of motion sickness susceptibility. But we didn't basically find any sort of major individual differences that would have been driving this effect.
Thank you, Anne. James, do you want to follow up on that, or here?
Yeah, I think thank you for asking that question. I think it's great and it's interesting to learn the study outcome. Because in various recent study that we conducted, of course, somehow in-house, and then the individual differences sometimes is so big to the degree that almost find certain type of bimodal distribution. Or even for this kind of time break study, you could have a group of people who need to drop out in the middle of a study, and then others might be able to last for an hour or even longer, and then without much of the issues. So certainly love to learn any signal around that. And then also a follow-up question I have is, given that various study has been showing some level, of course, it vary a lot, some level of individual differences, and then kind of curious about from your perspective, right? And then what kind of recommendation would you suggest for HND manufacturer or app developers? What should they tell their users, right? And then because we know people are certainly having different level of degree of susceptibility to motion sickness, and it will not be like a one strategy to work for everybody.
Yeah.
So yeah, kind of love to learn your take and any folks suggestion. Thank you.
Yeah, definitely. Thank you for that question. Look, I think that it seems as though longer breaks seem to be having more of an impact. As sort of, I guess, Dr. Stenya and I were busy talking about, it seems as though potentially the length of breaks might have an impact on reducing sickness. I didn't find anything with 10-minute breaks, but Dr. Stenya found some stuff with having 15-minute breaks. I have also done various studies showing that 40 minutes works for actually reducing those symptoms quite substantially. And I think in Dr. Stanley's talk, she said that 30 minutes actually worked as well, quite well for reducing.
No, 30 minutes in AR did not work.
No, but in VR?
Yeah, VR and AR are not working the same. So the AR was the one with 30 minutes, did not work.
Oh, okay. Well, I mean, I think it just shows that, so sorry for misunderstanding that, but essentially I think, it seems as though there still needs to be quite a bit of research and trying to look at those, what is the optimal type of breaks that, should be used for reducing symptoms. But definitely if you look at our study, that the longer breaks seem to be having a lot more of an impact on cyber sickness than the short breaks, which actually seem to have almost no effect at all. So I think perhaps that might be a good recommendation, is that once people have finished their VR session, to actually take longer breaks and to be very mindful of any symptoms that they might be experiencing, to just not do anything that might put them at risk during that longer break.
Yeah, I wouldn't be surprised if we talk about individual differences again, like in the breakout rooms. But let's quickly move on to the next question. Arash, do you want to ask your question directly? I guess it's for Uni.
Yes. Yeah. Thank you. So I think HEP is an interesting approach. So I was curious. So you talked about different waves. So why did you choose RPIC and then like even the duration of the epochs? So do you have I just want to know why you chose those values.
Well, actually, most of my procedure was referenced by the previous work. So the ERP analysis really cares about the exact time point of the EEG. So during the ECG signals, we should take the really sharp and some really positive points to take as an event. So that's why I also picked the RPIC as an event, and the time duration is also the typical time window for HEP amplitude. So that's what I choose, those range. Yeah.
Fantastic. Okay. Arinda, do you want to ask your question? Thanks.
Sure. Nice talks for everyone. So it's really, really insightful. So my question to Eunhee is that so many studies, many of your studies, when they use EEG particularly, they use those chin rests where you don't move your head at all and you experience this, the VR setup. But the problem is most of the VR environments that we deal with in daily life, they don't work like that. You really move, you interact. So my question is, the results that we are getting from those kind of controlled setup, how much do you think those results can be generalized to real world usage of VR?
Yeah, it's really good question. And I always wonder, well, my data can be applied in real life situations. So, well, to be honest, I'm not sure I can apply my data with chin rest can also reliably work in the real life context. But fortunately, I found some wireless EEG setup in the University of South Australia ECL lab. So I'm trying to set up those equipment, and I'll let you know if I found that I can generalize.
Yeah, sure. We should have a talk about it later on, but I think it would be good to see if we can measure it in another study to see how much the stationary results can be applied or how much variance are there in the real life setup, right?
Yeah, true.
Okay, great.
True.
Thank you.
Thank you.
Thank you. The next question I see is from Richard. Richard, do you want to ask your question directly?
Yeah, sure. Thanks. So my question was for me as well. In your study, maybe I just missed this, but I wouldn't have expected the inverted scene to cause less cyberstimulus than the upright scene. Do you have any theories or hypotheses for why that might be the case?
Yeah, actually, it is not my hypothesis, but the other researchers have mentioned that it might be related with the immersion, because we haven't experienced those kind of inverted contexts before. So we don't have much prior knowledge about how to deal with and perceive those totally opposite directional environments. So we barely immersed in those contexts, and even though the contents are really moving fast and dynamically moving, but participants didn't get much involved in those contents, and they didn't also report higher cyber sickness as well. Yeah, that's what I found in inverted scene.
Thank you, Uni. I can't see any other questions, I think. No, I can't. Oh. Has anyone a final question? If not, I'd like to thank the three speakers. I think these were really, really interesting talks. Thank you very much for that. And I hand over to Mark because he might announce a short bathroom break. I'm not sure.
Thanks for that. I'm not sure if we should have a bathroom break. We're running just a little bit behind time, and it seems like people who need the bathroom maybe could have gone before, but I'm not. Does anybody object if we keep on going, or if just to try and keep on schedule? I think it should be okay. So so now we have a speech from Richard from Mito, and I'll turn the time over to Mingzi to introduce him, and then he'll also handle the Q&A for Richard as well. And just as before, you can either put the questions in the Zoom chat or into the Discord, and then we'll take things from there. So over to you, Mingzi.
Right. Thanks, everyone. Now we're heading to our second keynote speaker session. So we will have Richard Yaw as a keynote speaker. So Richard is a UX research scientist at Meta Reality Labs. He has an extensive research experience in motion sickness and other comfort-related issues in VR. So previously, he got his PhD from UIUC with a focus on visual cognition and human performance. So today, he'll be talking about physical comfort in VR from an industry perspective. Richard, so it's your stage now.
Thanks. I'm trying to share my screen, but it says it's been disabled. Do I need to do anything?
Yeah, Tobias, can you make him a co-host? Yeah, so try now.
There we go. Okay.
Yeah, sorry about that.
Sorry. I'm not used to Zoom, so I'm trying to find the right window here. Sorry, just 1 second.
While Richard is setting up the screen, so just a reminder that if you have any questions during the session, so please feel free to post the question in the chat session.
Sorry, I'm not used to using Zoom, and now it's telling me I don't give Zoom permission to share my screen.
Right, then you might have to restart Zoom after.
Or yeah,
sorry about that.
Mac, yeah.
Permissions thing with your computer as well. So if any of you want to take a bathroom break while Richard resolves his problems, this will be a good time. It might be a couple of minutes.
Sorry about that. All right, I'll be right back.
That's okay. We'll take a break. It's okay.
Cool, we can see your screen now. Let's wait for 1 more minute. Okay, I think most of us are probably back in the room now. So Richard.
All right. So I should get started then. All right, cool. So thank you so much. It's a pleasure to be here. So when I was first invited to give this keynote, honestly, I was like, I don't know what I could tell this room that you guys don't already know, especially because in my work, I tend to leverage other people's scientific research, some of which comes from people in this room right now, more than I sort of conduct generative research, especially research that I can share in a broad audience. So, you know, I thought about it for a while, and I tried to think of something that I could contribute to this session that could only come from me. And so for my talk, I thought I'd share with you guys my observations of what it's been like to be a researcher in the consumer VR industry space for almost a decade now. So speaking of my opinions and observations, because I wasn't able to get this fully reviewed and approved in time by our comms teams, it's my responsibility and obligation to just note here that because this hasn't been officially reviewed and approved by Meta, you should interpret this purely as my own personal opinions and reflections on VR research. Nothing I'm saying here should be taken to reflect any official stance or perspective of Meta or the companies Meta owns. So now that's out of the way. Just a quick overview of my talk. I'm just going to try to present a few different views that I've seen in the VR industry around comfort and health and safety, and talk a little bit about why that is and how we got to the point we're at today, how these things have been changing over time. So just a quick introduction to myself. I already got a bit of an intro, so I can skip over a lot of that. Basically, the short story is I've been working on trying to figure out comfort in VR for about 9 years now. I started out as an experimental perceptual psychologist over at Oculus. We got acquired, and I've been doing research in this space ever since. And ever since I started, really, a lot of the work that I've been focusing on is in characterizing and preventing visually induced motion sickness or cyber sickness in VR. So to give you just the very short summary of my job description, basically ever since the beginning, you know, my bosses told me, hey, we want you to solve motion sickness. No problem. I mean, that's not something that humans have struggled with ever since they're humans, so this shouldn't be a problem at all, right? So this is me in 2014 trying to do that in front of an audience at our first Oculus Connect conference, which has been eaten up by Meta at this point, but we still had them. And I think part of why, sorry, let me back up. So, you know, we did know that motion sickness was an issue going into this endeavor of creating consumer VR. But honestly, there have been a lot of headwinds to sort of moving forward in sort of evangelizing and resourcing all the work that really needs to go into this to solve the problem. And I think a large part of that, at least early on, was sort of the very engineering focused mindset of the VR industry, because it was being built by hardware engineers. So an opinion that I constantly ran into and still occasionally run into is that maybe if we just better engineer blank, the issues will go away. And depending on who you're talking to, you'll get a lot of answers for filling in that blank. A lot of them make sense. But at the end of the day, for any human factor scientist, we all know, of course, that the problem is us. It's the human in the system. And for a while, the consumer VR industry, I felt wasn't looking at this in the correct way. You know, the analogy I always use with people is that, you the car industry doesn't talk about engineering car sickness out of cars. The airline industry doesn't talk about engineering air sickness out of their airplanes. And we're in a very similar position. There are a lot of things we can do to improve the experience. We can advance core requirements of the system, develop better amenities for it. But ultimately, it's us humans and our response to that sort of vestibular visual conflict that are really the limiting factor that we have to be thinking about if we want to try to reduce and maybe someday get rid of motion sickness. So from my perspective, I think that what I've been seeing in the VR industry is actually repeating the history of human factors in general. So, and just in case you haven't heard this story before, as the story goes, the aviation as a field was starting to hit an engineering ceiling. Basically, as aviation engineers were trying to get incidents and crash rates down further and further, they were hitting an asymptote and were running out of ways they could improve the plane itself to increase safety. And it occurred to them that the limiting factor here was the human, and we need to start engineering these things towards the human being inside this system who's piloting the thing. And I think a very similar, when a very similar attitude starts pervading the VR industry, then we're going to see much more focus on that human in the loop. That's not to say there isn't a lot of research in that space already. A lot of consumer VR companies do have whole teams dedicated to human factors and exactly that kind of research. But as a consumer outside of the VR industry, when I see what just everyday tech enthusiasts are consuming, and even as someone inside the industry interacting with developers and creators, I find that discussions of motion sickness aren't as common, aren't as sophisticated, just aren't to the level that I think they really need to be in order for us to make some really strong, significant advances in this area. And so I think that the reason why you see this is really due to some additional kind of obstacles that we have to overcome. So one is just a practical limitation of any business. Not everyone experiences motion sickness. And if you're in charge of development on a VR game, and say, you're in charge and you're one of the people who just doesn't experience motion sickness at all. And we do find in our research that there's some people who are completely resistant to motion sickness in VR. It's not going to seem very important to you to be trying to figure out some, novel design to try to reduce motion sickness. But something that I've personally observed over the course of numerous studies is that there's also this data limitation in what we get from open-ended user feedback. In any business, obviously, if you want to start moving that ship in a certain direction, you have to provide a lot of clear data that justifies that there is a problem and we need to solve it, and this is the value it's going to provide us. And a big source of data that's used in making those decisions is open-ended user feedback. But as I'm going to describe here, it's been historically kind of challenging to get that sort of free-form information on comfort volunteered from our consumers. And I'm going to explain that as sort of in the history of what kind of feedback we've gotten back from our users. So back in 2016, the first consumer model of the Oculus Rift launched. It was a great historic moment for Oculus and Facebook at the time. And although it was called consumer VR, it was consumer VR in a very loose sense. It was still kind of out of range price-wise for a lot of people. The Oculus Rift itself, plus the controllers, alone cost about $800 together. And this wasn't even taking into account the necessity for a rather high-end gaming PC at the time. So even if you wanted to go for a lower fidelity experience and use one of those systems where you sort of slot a smartphone into a headset mount of some kind, even then you're having to get like the latest generation smartphone, and those are going to be expensive as well. So something that I was hearing again and again is that people just couldn't afford to enter VR. That was a recurring theme in those early days of VR. I put here as an honorable mention that a lot of people also just didn't feel like they had enough time and space in their lives to play VR. Besides being expensive, people often felt that their lives were too busy to have to set up and use this VR system. And even if they could, their homes didn't have these nice big open spaces that would be necessary to really enjoy the system to its fullest. But the main problem to focus on here is really just this price of admission. So in response to all this, the Oculus Rift and the Touch had a major price drop. The price was knocked down $200 just to get it into sort of a reasonable consumer range. And that helped move the needle a little bit. That went twice. In 2017, a year after the headset was first launched, the price was dropped, obviously, in order to populate the store for this headset. Some content development funding began. And that continued into 2018 when the Oculus Go was released. And the Oculus Go is important in that it provided the first affordable standalone VR experience for people. So it was very similar to the smartphone experience where you had a small headset that you could put on. It didn't have full 6 degrees of freedom tracking. It basically only detected rotation of your head. It had a very simple remote, but you could still build games for this system. And since it didn't have any other requirements for actually running it, you didn't have to buy a new phone, you didn't have to buy a high-end computer. This was really considered the first true consumer VR experience. So as more people started getting headsets in their homes, started using them, the feedback that I was observing started to take on a new form. Price was no longer a primary concern for people. It was within the range of affordability for most people. But the recurring theme now was about the content ecosystem. So people would ask, what's this headset good for? What am I going to use this for in my life? So, excuse me. We're now hitting this new obstacle, which is that people could afford VR, but there wasn't really enough reason for them to, if they hadn't bought a headset already, to actually, want to invest in it. And then when they had it, enough reason to sort of stick around and keep playing with this thing every day. So with all the resources that Oculus and Facebook and Meta had, there is, they supercharged the development space by pumping a lot of funding into VR developers. And this is even continuing today into their metaverse app in order to sort of create new experiences and new attractions for people to want to enjoy in VR. The real killer app or at least what I should say is often credited as being a killer app for VR, was the game Beat Saber. So if you haven't played the game, I'd be surprised if VR researchers haven't played this game at this point. It's basically a rhythm and music game where these boxes are flying towards you, and there's like all sorts of music at this point. I was going to say like electronic music, but music is playing while these boxes are coming at you, and you have these two lightsabers, and you're hitting the boxes in different ways in time with the music. It's really satisfying. It had a wide appeal. Anyone could pick this up and play. It was very arcade-like. And my own personal theory for why it felt so immersive for a lot of people is that as far as we know about lightsabers, they're pretty light, and if we whacked them through boxes, we'd barely feel anything at all. So it provided this very immersive, haptically realistic experience for people. Incidentally, that's also why I think table tennis games are very popular in VR as well, because it very much matches what you would experience, the sort of tactile experience, in that you don't have to feel much resistance on your hands. You just feel like a little bump, and controllers are capable of delivering that. So on top of that, this game was very accessible because it didn't induce any kind of sensory conflict. There's still the occasional person who might still feel a little weird from playing a game like Beat Saber, just from the sheer motion of everything. But because there wasn't any fundamental vection or sensory conflict there, the game could be played for a long time without experiencing any kind of motion sickness, and that led to a lot of adoption as well. So we had this game that people wanted to play. The Oculus Go didn't let people play that on their headsets yet, because it didn't have all the technology required. But that changed when the Oculus Quest was released and delivered the same kind of experience that PC VR was giving people, where you had a single headset, you had controllers, and they all were tracked with 6 degrees of freedom. You could rotate your head, but you could also translate through space. And importantly, you could play a game like Beat Saber. So really, it wasn't until 2019 when the promise of consumer VR was finally truly delivered. People had very specific expectations for what it meant to be a consumer VR system, where you didn't have to buy any additional hardware, you didn't have to buy, you didn't have any kind of real dependencies on using this system. Everything was just there for you. There were games, there were things you wanted to do. So really, if in the history of consumer VR, this is really when things finally truly took off, and you could really say that for the average person, what they thought of consumer VR was finally real. And of course, this was iterated upon in 2020 when the Quest 2 came out. The cost quality ratio was brought down even further. There are some iterations on the design. But again, we finally reached this point where we have a device that people can afford, they want, there's stuff to do in it. And so finally, we're starting to go beyond the basic requirements. And I accidentally said everything that's on my slide already. So yeah, the cost was in range. We had full 6 DoF tracking out of the box. There was a large, rich content library that was sufficiently appealing. And so now we were in a situation where people could afford VR and they wanted to stay in it. But now they were starting to finally notice that physical discomfort could keep some of them from playing as long as they'd like. People wanted to play with their friends in VR. People wanted to ride roller coasters and fly around space in VR. But for those who are susceptible to motion sickness, that was becoming a limiting factor. So this is the stage that we're at with consumer VR right now. It's only now becoming, the clear and obvious obstacle for further, adoption in the VR space. And it may be surprising to sort of the scientific field that understands these kinds of issues, obviously, because science, the industry is going to lag behind the science to some degree, and the public's understanding of what even the industry knows is going to lag behind by an order of magnitude as well. So, I still run into people who are in the VR industry. I run into consumers who just have no idea what causes motion sickness in VR. They just know it happens, either because they've experienced themselves or they heard it happens in VR for some people. But this is becoming kind of the new obstacle that we have to overcome. Motion sickness is becoming one of the top reasons people cite for being apprehensive about using VR if they haven't invested in it yet. And it's even one of the top reasons for that people cite for making an app return. And so this is only in the very recent history of Quest 2. So this is sort of my unified theory of kind of why comfort hasn't sort of been at the forefront until very recently. It was because we had these sort of it was sort of like Maslow's hierarchy of needs. People who could only reach one level couldn't reach the next one below it, and sort of offer up feedback to it. So there's at the top this price of admission. I call this the consumer VR funnel because as we go through these steps, we progressively lose some people, and it's the VR industry's goal to try to lose as few people at each of these stages as possible. So the first question people ask is, can I afford this? Do I have the money? Do I have the time? Do I have the space to enjoy VR? And if the answer to that is yes, the next question they ask is, okay, what am I going to use it for? What's there for me? What's going to keep me coming back? The challenge here is that even if the way consumer VR is now, it can draw a sizable audience, but in order to really get a lot of people, the people who are sort of on the edge of whether or not they want to use it, it often comes down to sort of what's unique about this. Why would I want to do this more than any other form of entertainment that's already available to me? But if we can convince those people to invest in the VR headset and stick around, that's when we start to reach kind of the issues that we here in this workshop are really interested in, which is these health and safety and comfort issues. Only then do people start to notice that, hey, I'm experiencing some motion sickness from this, and I really wish there was something I could do, or something that these developers could do, or the VR industry could do to fix that. And so only when people sort of reach this level do they start volunteering this information. And so that's sort of why I believe when collecting feedback, internally through our research, through user feedback, through surveys, through market research, we didn't really gather kind of a critical mass of data that said, this is a real problem that needs a lot of attention paid to it. So, there's still a clear line of sight towards some hardware improvements that could be made. So that's still happening. But I think more than ever before, I believe VR has really finally only recently reached a sufficient level of maturity that actually matches what people think of when they think of consumer VR. And so since we've started to overcome those earlier requirements, those more fundamental requirements for people, these more obvious and prevalent limitations are being removed. And only now are we getting a better signal on some of these subtler ones that aren't going to affect people until they've been using and trying to enjoy VR for a while. So I think now more than ever, the industry is going to be looking to, researchers and scientists like the people in this room right now, more than they ever have historically. And incidentally, I'm just going to slip in here that if you were to go to the Meta careers page, you would find job openings for research scientists in the health and safety space. So just to put that out there as a shameless plug. Thank you very much for listening to my talk, and we can open up to questions.
Thank you, Richard, for the talk. So while our audience coming up with questions, I have one question. Obviously, we see the improvements in terms of Quest over the years. I wonder, before every time we introduce a new design that perhaps reduces the motion sickness and other discomforts, how do you measure those improvements? Do you, from the industry perspective? Because I think most of us from the academia, and we have quite limited access to participants. We want to have the wide range of participants like Meta does. I was wondering, do you run those studies or measurements in a more like a social science style or like a clinical style?
I'm trying to think of a way I can safely answer that question, that I'm allowed to answer it. So Dr. Stanny mentioned earlier in the workshop that even with technologies today, we see a lot of the same issues that we were seeing in even old technologies from decades ago. And I think in a lot of ways that's true. But at the same time, there are tangible improvements that we can point to every generation that, there is improved ergonomics, there is improved, thermal control even, which is also another commonly cited piece of feedback we've gotten. We do have these sort of categorical improvements from generation to generation. But I think a lot of the fundamental issues with comfort that arise from these sort of sensory conflicts are really still a challenge that we're still actively working on even now.
Thanks. So we have a question from Kay. Kay, do you want to ask that yourself?
Sure. Can you go back to the the one that has the displays through 2020?
Yeah. The timeline, you mean?
Yeah. So in here, how has the design evolved? Like what specifically within these has evolved to enhance comfort?
So some of the things people will often point to are the display technologies. So lower persistence displays. There's some bumps in resolution along some of the generations. There's been a lot of work on sort of the design of the straps and how the headset, the device itself, is supported on the head. There's been a lot of iteration. There continues to be a lot of iteration on that. Let me think. The optics have improved across generations. So the original Rift 1 lenses created a lot of ghosting, and people often call them the God rays. They were coming from internal reflections in the Fresnel lenses. Those were brought down. So I think those are the things that I can think of off the top of my head.
So do you think we'll ever go to an open periphery and completely adjustable IPD, like that would fit all IPDs, automatic calibration to everybody's IPD as well as open periphery?
Yeah, I think when it comes to trying to design these in the consumer space, everything comes with trade-offs. So I've been in a lot of conversations about open periphery and some pros and cons to this. So there is the potential for providing you this viewpoint to the outside world and providing sort of more of a grounding stimulus that allows you to feel like you're stable and not kind of create as much of a sensory conflict for you. But depending on the use case, that sort of introduces now issues with glare from outside of the headset that can reduce contrast, can reduce overall visual quality of what you're seeing in the headset. And for a lot of people who are very core diehard VR gamers, that can be a real deal breaker for them. So that's not to say this wouldn't be fine in other contexts. Maybe if you're not a serious gamer, maybe if you just want to watch the movies, either traditional or immersive, or you're doing some simple video conferencing where or telework where high visual fidelity is not necessarily your priority. That is a viable option and something that would be a reasonable trade-off to make. So yeah, I think it's difficult to say that we can design some ideal headset for all people all at once. I think there are going to be different considerations and different priorities for different people and different use cases.
Thank you.
We have a few more questions from the chat session. So Anchor, so you have a question, so you want to ask that?
Hi, yeah. Thanks, this is a very interesting talk. I guess my question is that there's a lot of virtual reality research like in adult populations, so sort of 20 and plus. But we know that also sort of younger kids and sort of adolescents also use VR headsets. So my question is, does Oculus Meta also look at younger populations when doing human factors research and considering sort of design changes as well?
Yeah, that's a great question. And again, something I have to think about in terms of what I can safely say. I mean, it is absolutely a concern. The official stance is that, our headsets are, designed for this adult population, but practically speaking, there are younger users who want to get into it and want to use VR. So, it is something that, we are thinking about, but I'm afraid I can't get into it much further than that.
All right. So we have another question from Tobias.
Yes, thank you, Richard, for this interesting talk. I think I also have like many questions you are probably not able to answer here, at least. So a more general questions in terms of funding. So we have been trying to get funding quite a lot from like national funding bodies. And I wonder what would be sort of your killer argument for us to use that they think this is a really important issue. I'm not talking about the defense and army funding, but more like a national, medical funds and so on. And the feedback we typically get, oh yeah, it's important, but it's also too niche. In comparison to curing, I don't know, dementia or like cancer. So I wonder whether you can give us some advice of what kind of arguments would you sort of put forward to such a funding agency?
Off the top of my head, I would point to the increasing adoption of VR technologies, both in the consumer space, but also in the enterprise space. There are more and more people who are using virtual reality for training purposes. Meta has it has a whole sort of, what's the word I'm looking for? Basically, there's a whole VR for enterprise product area, I guess, that Meta deals with, because there are so many companies that are using it for training new employees, for educational purposes, for continuing education. I think there's just in general more investment and growing use cases for VR, just in general. And I think I don't know all the stats off the top of my head, but the data is out there to point to the growing interest in and increasing use cases for virtual reality among the general public.
Well, thanks, Richard. So we have next question from Nicholas. It's about lens distortion. So Nicholas, do you want to explain it now?
Yeah, can you hear me?
Yep.
Perfect. Okay, so I was wondering, because you had like these different headsets, and I think you also use different lens designs during the different headsets. I think you mentioned something like that. If you can kind of elaborate on the influence of like lens distortions on motion sickness.
Yeah, so and this is known information, just there is some sort of field curvature to the lenses that's constantly trying to be optimized. So there's going to be an optimal zone that you can gaze through that we want to that's going to provide a clear image, and we want to increase that as much as possible. But because of the field curvature, there's also there's also slightly varying distortion depending on which angle you're looking through the lens. So there is that is kind of an ongoing challenge, optimizing until we have full eye tracking and knowing exactly how a person is gazing through the lens. We have to sort of try to find a balance for how to optimally distort or pre-distort the image before it sort of gets distorted again by the lens. And that's a very active area of discussion. But I think it's pretty well established at this point that IPD alignment it also plays a role as well. Depending on how well you're again able to look through that sort of optimized part of the lens to the display is also going to contribute to comfort, which is another reason why we're constantly trying to optimize the pupil box there, the zone in which you can gaze through the lens and get kind of a clear and nice image as we expect. So yeah, I think I don't know if I think dynamic distortion correction is sort of the closest to what I think your question is about.
Yeah, I mean, I came from like an optical background thinking, like because you have similar symptoms whenever people get new glasses, you also have this kind of motion sickness kind of symptoms, and after a while you adapt to your glasses. And I was wondering if like that is an area you are already looking at.
Yeah, absolutely. That is so I can tell you that is a concern for, at least from what we've observed. The people who are who experience cyber sickness purely from the distortion alone are in a very, very small minority. Much more of the cyber sickness people experience from VR seems to be coming from sensory conflicts. So that's not to say there isn't this group of people who are sensitive to and experience sensory conflict as a result of that distortion. But it is kind of a known issue and something that it is an active area of research and design.
Thanks.
All right, we have another question from Kay. Kay.
Thank you. I have to ask if you think VR can compete with AR, since you can go fully immersive in the AR headsets and you don't have the comfort issues.
I'd say it's hard for me to say. I think if you're going fully immersive with an AR headset, you're still supplanting the visual stimulus, sort of the visual signal that your brain is getting. So you still have, I would say, you'd still have a high potential for motion sickness there, unless there is some reduction.
I got to tell you, it's not happening. We're going back and forth, and because we go back and forth, we're not seeing it. I thought we would. We're not. In the AR, we're not seeing it. We're not seeing the discomfort because you're going back and forth. So a lot of subjects and a lot of evidence that the comfort issues just aren't there in AR. And we do go fully immersive, but we go back and forth.
Sorry, can you elaborate on what you mean by going back and forth?
So we'll have parts of the experience where it's fully immersed, and everything's occluded, like a battlefield, right? We do a lot of stuff with the military, so we'll have a full battlefield, complete occlusion of the real world, and then we'll go into particular activities where you're mixing AR and real world. And so you're going back and forth between AR overlays on real world assets and immersive battlefield. And we're seeing no gut stuff whatsoever, no discomfort.
Yeah, I mean, that totally makes sense in terms of the degree to which you're replacing the visual signal and inducing vection. I don't know if we necessarily want to say that we're these are kind of mutually exclusive technologies, or that they're necessarily competing with each other. I think they offer different there are pros and cons to either technology, and there are going to be different use cases that are optimal for either one. But yeah, I mean, I would totally agree with you that they are just by nature of how it works and how it's used is always going to be across the board, just less likely to induce cyber sickness.
Thank you.
All right, so I have a last question. So for headset manufacturers like Meta and others, do you have any sort of comfort threshold or discomfort threshold? For example, the SSQ must be within certain range before you could consider releasing the headset to the public?
Yeah, so it's been sort of, so a major instrument we use is the SSQ, and I don't have the numbers to share with you. I'm not sure if I can share the numbers, but basically we want to try to compare the experience of using the headset to what the sort of expectation you would get, or the sort of data you would expect to get on the SSQ from other activities that exist out in the world that we know sort of people will tolerate, that are sort of within the range of reportable discomfort that people experience in other use cases, other contexts, other experiences. And so, in using VR and not inducing any kind of sensory conflict, we find for almost everyone, a fraction of percent of people are the exception, but for nearly everyone, that they fall within this range of SSQ measured comfort for very often just coming in from a hot day, or riding on a bus for a little while. The degree of discomfort people report is well within the range of just daily activities. Obviously, that changes significantly when we do induce sensory conflicts. So that is still a known problem that we want to try to address and make progress on. But yeah, that's sort of, I think that's that's kind of as much as I think I can probably disclose in terms of describing kind of the tolerance that we're looking at.
All right, cool. Thanks very much for the amazing presentation and the wonderful Q&A session. Now I'll hand this back to Mark.
Thanks so much. Maybe you can stop sharing your screen, Richard. So thanks. There's some really insightful comments, both from Richard's talk and then from the papers before, and then Kay's talk. We're coming to the last session now, so we're going to probably for about 25 minutes or so, we're going to break into two breakout rooms, and I'll turn the time over to Barrett, and he'll explain what's going to happen with that. And then we're going to have a discussion for about 20 minutes in each of those rooms about what research topics we think are important in the health and safety area, and then we'll come back around 2 o'clock to give a quick summary from the two groups. So Barrett, do you want to explain how it'll all work?
Yeah, so we're going to go into some breakout rooms here, and then we're going to join, I'll send out some links to a couple of mural boards. So we'll have one for each group, and essentially the aim, we'll have to do this very quickly, I guess, but we'll generate a bunch of topics of interest. I think there's lots of stuff coming out of these inspiring discussions today, so I think that will be easy. And then, so do that very quickly, try and group these into themes, and then the aim is to try and prioritize what we think are the most important themes and have a quick discussion about what some potential research is in that area. So it'll be a bit of a whirlwind to do. What time do you want to try and meet back here, Mark?
It'll be good to get back at 2 o'clock in New Zealand, which is about 25 minutes from now. Would be great.
So we'll have.
I've noticed we've had some people drop out, so it looks like we'll have two rooms of about 8 to 9 in each room.
Yeah, okay, and then we'll have a quick recap when we come back. So I'll just assign everybody randomly to breakout rooms. Here, what I'll do first is post the link. So I'll lead group 2, and we have where's
Arash?
Arash.
Yeah, he'll be.
Arash will be group 1. So I'm just going to send the links here so we have them, but we can repost these in the
chat afterwards. Yeah.
Grab these. It's giving me a hard time. There we go. And we'll repost these within the breakout room. Actually, I think the chat persists into the breakout rooms. We'll see. If not, we'll repost them when we go in. And then I'll try and put an equal number of, oops. Add a room. Okay. So 2 rooms, and I'll try and put an equal number of organizers and other people in there. See, so who's the hosts? Okay. Unfortunately, it doesn't list everybody by. I can't see who's the co-host in the list. Do you know what I'm going to do? Just because we're short of time, I'm just going to kind of put everybody.
Yeah, just for every second person in the other room, that'll be quick.
Just bear with me for one moment. Okay, and that works. Okay, so some of you are assigned to room 1, I think. There's a rush there, and the rest will assign to the other room.
Great. So I'll join. Yeah.
I think that's we have everyone. Did I miss anybody? Okay, let's in the rooms and we'll meet back here shortly. All right, Richard, did you get assigned to a room?
I guess I wasn't.
Okay. Let me fix that. So Ash is in room 1. I don't see you. Okay, let me So I don't see you in my list. It's really strange. Oh, you're the host. Do you have a breakout room button at the bottom?
Yeah. Says I can join either. It didn't assign me to one. Is it supposed to assign me to one or?
Hey everybody, we're coming back. Great. Oh, it looks like we've lost a couple. There's only 14 people now. Great. 15. So I think we're all here, Barrett. Do you want to lead the summary session?
Great, yeah, so thanks everyone. This looks great. I was just looking at the other board as well. So we'll go first. Maybe we'll ask group one to go first. And I think what we want to do is just very briefly, if in 5 minutes or less, or maybe even 2 or 3 minutes, try and give a summary of the topics that you found in the board. So maybe if somebody can present for group one, maybe share your screen and show us the actually, I can just share my screen for both groups, and then maybe somebody can, if somebody from group one wants to lead the discussion and let us know what you found in group one.
I think I can go from group one. So we talked about different topics, and I think majority were kind of like wrapped around still motion sickness. And the concerns that we have. And we identified basically 3 main parts for the motion sickness. One part is basically there are several mitigation techniques that we might have, and then the causal factors that why it's happening, and then the design understanding and design guidelines that we need to provide to have a safer design. But when we and then there are 3 other topics. One of them is situational awareness. So spatial navigation is part of it, the visual attention management in AR, and basically the mixture of visual and physical objects and the spaces that we have in MR. So that's for like situational awareness and design factors and risks associated with that. And then we have accessibility, for example. So in this, one of the example we had was basically cyber sickness might cause some people to not be able to use and fully immerse the virtual environment. So that's a concern. So we need to think about how we can make it more accessible. And finally, the use safety in metaverse. So basically, and then we had a voting. So on the right, basically, these are the votes that we have. So one, basically, the first thing that got voted basically is the use safety in metaverse, research that we need to spend more research on it. And then on the design, establishing extra content that design guidelines that assist mitigation strategies for cyber sickness. And then for accessibility was the third one, basically the magnitude of the cyber sickness problem that I mentioned. And finally, for the situational awareness, the visual attention management in AR, especially involving in the transportation when the person is walking around, and for us to make sure that we're not causing any risk to the user.
Great, thank you, Arash. That was very nicely done and very timely summary. Thanks. And then, okay, so from group two, our board looks a little different, and I think Ankre is going to speak to ours.
Hi, thanks. So yeah, so I mean, I guess there's an overlap. So it's quite interesting to see what some of the overlaps are between the 2 groups. But it seems as though for our group that the hot topic was objective measures. So sort of, being able to, I guess, use physiological measures for health and safety, trying to find out what are sort of reliable, meaningful measures. There's some questions about whether the SSQ is a good enough questionnaire. And some stuff also around motion sickness susceptibility as well, and making those comparisons between subjective and objective measures. The second most popular topic, I think, was specific populations. Is that it?
These 2 are tied. Real world impact and specific.
Yeah.
Yeah, so we had a tie between real world impact and specific populations. So it seems as though a lot of people thought it was really important as well to also look at the youth population, but also other demographics such as the elderly where I guess, as training and things are moving more towards these peripheral spaces, that it is starting to include in some of these groups and other demographics that maybe might not be part of the sort of gaming aspect. And then looking at real world impact, there were some questions about also sort of visual impact. So looking at eye strain, accommodation and convergence issues, whether this might correlate with cyber sickness, and is adaptation to virtual environments a risk for real world risks as well? And quite importantly, how does cyber sickness affect real world activities such as driving? And again, there's also some questions around augmented reality as well. How does impact of distraction affect augmented reality?
Great. Yeah, so what I guess what are the most strongest overlaps between the two groups that we have here?
Well, the young is a common theme, I guess. In the first group, it talked about youth safety and metaverse, but I guess the second group was thinking more about the health impacts, which I guess it's a little bit different from safety impacts potentially. In terms of,
yeah, I think situational awareness seems to overlap with this real world impacts. Maybe specific populations, or maybe there's some overlap between those as well. But causal factors, yeah, it's interesting how different the two are and similar as well. Great. That was fun. And very nice kind of whirlwind exercise. Thanks everyone for keeping on time and yeah.
So that brings us pretty much to the end of the workshop. There's a couple of housekeeping things, I guess. I want to check, especially with Ankarit and with Cheryl, if it's okay for us to put your papers onto the workshop website. And I don't think you have a paper that goes with your slides, so you just have the slides. So for those of you, if it's okay, I'd love to put your papers on the website. And then there'll be a recording made of the workshop, and I think we are allowed to put that up as well. And then Barrett, I guess it'll be good maybe to make a PDF or something of the mirror boards, so we could put some. Is that possible with Miro to make a PDF?
There should be a way to export it. We'll see. It might be like a pro feature or something like that, but I think I'll look into it and see. If not, I'll do a screenshot.
The worst case is to make screenshots, I guess, but yeah. But yeah, so thanks for your contribution. I'm not sure, Barrett, if you want to say a few last words, or maybe go around all the organisers to see if anybody wants to say anything.
I just want to say thanks. It was really nice meeting everybody. That there's a lot of people I haven't met here before, and even some of the organizers I haven't met. So it's really great. Been a good experience for me. And thanks to Mark for organizing this. Mark did a huge amount of the work to put all of this.
And Toby put a comment in the chat about how he'd like to talk to some more, put open platforms down on the Miro board, so you can reach out and contact them.
I also have a question. Where should we go from here? We've got now the Miro board. Should we sort of try to keep connected in a way? Because I feel looking at the study that are published, we often have quite a few participants. Between 20 and 40, but I don't think we will answer big questions with these small samples. So one idea is definitely like the open platform. I personally think that we could sort of think about, but I don't know about like other things, whether there's a way to sort of keep connected or like to work together, like also like for like even like for funding up applications, having like international collaborations or something like that would be probably really good to have. I don't know whether like anyone has specific ideas or thoughts on this.
Well, that's a great. So a couple of things. One is if people are interested, I would be happy to put together a proposal for a special topic in a journal. So there's a journal that I'm editor of that we could put forward, or we could also look at something like Frontiers or something like that. So if there's enough interest amongst the community, then that would be could be good. And then in terms of keeping momentum, one option would be to run another workshop in future conferences. So the upcoming ISMAR conference, for example, will give us an opportunity to run a workshop in October. We could do another workshop in VR next year. And some of the other workshops on the schedule for VR have been running for 5 or 6 years. You know, they run them every year. So that's another opportunity. Does anybody else have any other ideas of how to keep the momentum alive?
Mark, there's also the Discord. So there's
that's true.
a channel for this workshop that people could kind of follow up the discussion. I don't know how long it stays open, but it should be open at least during the rest of the conference.
Yeah, at least during the conference, and
maybe people can kind of meet there and discuss ideas as well of how to follow up after the conference.
That's a good idea. Yeah.
So I think the Discord from last year's VR is still online, so they seem to be quite stable.
So maybe Mark, along with the sort of the summary and the PDFs of the notes and everything, we could send along a reminder to join the Discord and have some follow-up discussions there.
And Alison's making a suggestion of creating a mailing list. So I guess we could make a Google spreadsheet and put the link into Discord and saying, if you're interested in this topic, please put your name and email address in the spreadsheet. And then after VR is over, we can make a mailing list with those email addresses potentially.
I think you may get the, I'm not sure if everybody registered for the workshop or not.
No, they didn't register because it was open to everybody who's an IEEE VR.
Yeah, I think you might be able to get the list from the Zoom chat. They may give you access to, the organizers may allow you to look there to get the list of.
Who actually joined the workshop? Yeah, that's a good idea. Yeah.
The Zoom chat will have everybody's like.
Yes, when they, I guess they'll give us the transcript when they first the recording as well. Yeah. Does anybody have any other thoughts or feedback?
Thanks for organizing the workshop. It was great.
Oh, well, thanks for coming. And you've been up late now, okay? So thanks for staying up late. Must be was it 1 o'clock in the morning for you or something?
No, it's just way past dinner time.
Oh, okay, great. Oh, Nicholas is up late. It's true. Yeah, I guess it's nearly 2 o'clock for you. Yeah.
Big thanks to Mark, and thanks to all of our presenters.
Great. Well, thanks everybody, and we'll see you later during the conference. So hopefully a lot of you will be able to connect up during IEEE VR, and there'll also be papers in the conference that are really relevant to health and safety as well. So thanks everybody, and we'll talk later then. We'll see you later.